Discover how the world might end in this calm, bedtime-friendly series. From ancient myths and cosmic threats to climate change, pandemics, nuclear winter, artificial intelligence, and the heat death of the universe, each chapter blends history, science, and philosophy. Relax, reflect, and explore humanity's resilience, lessons, and fragile hope in understanding Earth's ultimate fate. When we imagine the end of the world, the mind often fills with dramatic images: fire raining from the sky, oceans swallowing cities, or civilizations crumbling under their own weight. Movies and books paint it in flashing colors of disaster. Yet the reality of thinking about endings does not have to be terrifying. It can also be a way of better understanding life itself. To explore how the world might end is, in truth, to ask how precious and unlikely it is that we are here at all. This journey is not about frightening predictions, but about approaching the subject with calm curiosity, with respect for science, and with a sense of wonder for the fragile, resilient planet that is our only home. From the moment human beings first looked up at the stars, we have carried questions about beginnings and endings. Ancient myths told of floods, of fire, of gods who reset creation when balance was broken. Modern science offers a different set of possibilities: climate shifts, cosmic impacts, nuclear winters, or even the slow, inevitable cooling of the universe itself. What unites myth and science is not the details, but the longing to make sense of where we stand in time's long arc. To speak about the end of the world, then, is to engage with some of humanity's oldest questions. What forces shape us? How long can life endure? And what choices do we have as caretakers of this extraordinary planet? Setting ground rules matters before we take the first step. The first is respect. Every culture, every tradition, every field of science has its own way of picturing endings, and none should be dismissed out of hand. A story told by a Norse poet, a prophecy remembered in the Quran, a graph drawn by a climate scientist, and a model from astrophysics all belong to the tapestry of how humans understand their fate. Even when they do not agree, they remind us of the same truth. Life is not guaranteed, and awareness of its limits deepens our appreciation of its beauty. The second ground rule is empathy. Endings are not abstract. They touch on human fears, family hopes, and the future of children yet unborn. It is easy to talk about extinction in numbers and probabilities, but behind every calculation lies a quiet reminder that what is at stake is us, our memories, our art, our language, our laughter. When we imagine asteroid impacts or rising seas, it is not just geology or astronomy at play, but people, coastal villages, small farms, crowded cities, and the countless acts of care that fill ordinary days. To reflect on the end of the world is also to reflect on the deep ties we hold to one another. The third ground rule is perspective. Many of the scenarios we will encounter, cosmic explosions, the sun's expansion, the heat death of the universe, take place on scales so vast they are almost beyond human imagination. Billions of years, distances measured in light years, energies greater than anything we could ever harness. Others, climate change, nuclear risks, pandemics, are measured in decades or centuries, squarely within the lifetimes of our children or grandchildren. Some are natural, some are of our own making. Keeping perspective means learning to hold both truths: that humanity is small in the face of cosmic time, and yet powerful enough to alter the course of its own history. The fourth ground rule is calm curiosity. Fear can freeze us, but curiosity opens doors. To ask, how might the world end, is not to surrender to despair, but to explore the edges of knowledge. It is to look at Earth as both fragile and strong, as vulnerable to chance and yet remarkably adaptive. Scientists have pieced together stories of mass extinctions from rocks and fossils, traced climate cycles through ice cores, and modeled planetary orbits with mathematics that stretches back to Newton and beyond. Each of these discoveries does not only warn us of danger, it teaches us something about the extraordinary complexity that allows life to exist in the first place. Finally, there is the rule of balance. This is not a story about doom alone, but about resilience, imagination, and choice. The end of the world can be imagined in many ways, but the truth is that humanity has survived countless trials already. Ice ages, plagues, volcanic winters, wars, collapses of civilizations, all of these have scarred human history, yet also revealed a pattern of endurance. When we explore potential endings, it is equally important to recognize beginnings, to see how each challenge in the past has given rise to new forms of life, new cultures, new knowledge. Balance means holding fear and hope together, never allowing one to erase the other. So, as we begin this exploration, imagine yourself as both witness and traveler. You are standing at the edge of deep time, looking backward at the billions of years Earth has already lived through and forward into billions more that stretch into the future. You are hearing the echoes of ancestors who told stories of floods and fire, while also reading the graphs of climate scientists and astrophysicists who plot trajectories of stars and planets. You are part of a species that builds nuclear weapons, yet also builds telescopes to search for other worlds. This duality, fragile and destructive, creative and resilient, is at the heart of what it means to think about the end of the world. In setting the tone for what follows, reassurance is as important as explanation. The vast majority of cosmic threats, asteroid impacts, gamma-ray bursts, or the expansion of the Sun, exist on timescales far beyond our lifetimes. They are real, but they are not tomorrow. The more immediate risks, climate change, resource depletion, nuclear conflict, are within our power to mitigate. Knowledge is not a sentence of doom, but a tool for responsibility. By calmly understanding the many ways life on Earth could be threatened, we strengthen our ability to prevent or adapt. To face the idea of the end of the world with calm curiosity is, paradoxically, to learn how to protect it better. There is another reason to walk through these scenarios gently. Awareness of endings teaches us to live more deeply in the present. When you know that stars eventually exhaust their fuel, the sight of the night sky becomes even more precious. When you know that civilizations have risen and fallen before, the ordinary act of walking through a city feels more profound. When you know that ecosystems can collapse, the song of a bird in a garden feels like a gift. Reflection on the end sharpens our sense of the now, reminding us to hold with gratitude the fragile abundance of life as it exists today. We will explore myths and prophecies, because they reveal the oldest ways humans have imagined catastrophe and renewal. We will explore cosmic risks, because they show how dependent we are on the wider universe. We will explore geological and biological changes, because Earth itself is never static. We will explore human-made dangers, because our species has reached a point where our technology shapes the fate of the planet. And we will explore resilience, philosophy, and hope, because the end is not only destruction but transformation, a reminder that every horizon carries both endings and beginnings. So let this be the invitation. Set aside fear for the moment, and instead imagine you are listening to the story of a planet, our planet, as told across ages and disciplines. The end of the world is not a single date circled on a calendar, but a spectrum of possibilities. Some may never happen, some may arrive sooner than expected. Some may only occur after humanity is long gone, leaving Earth to continue its own story in silence. To listen to these possibilities is not to surrender, but to prepare, not to panic, but to reflect, not to despair, but to marvel at the strangeness and wonder of existence itself. The ground rules are simple: respect, empathy, perspective, calm curiosity, and balance. With these in place, we can step carefully into a subject that has frightened and fascinated for millennia. The end of the world, whether imagined through myth, science, or art, is ultimately a mirror held up to life itself. And so, as we begin, breathe deeply, knowing that to ask how it might end is also to affirm that it is still here, still alive, still worth protecting. Long before telescopes revealed galaxies or satellites traced Earth's orbit, human beings looked toward the horizon and wondered how the story might close. Every sunrise was a reminder of cycles, and every nightfall was a quiet rehearsal for endings. The oldest cultures imagined that the world itself was not fixed, but fragile, and that someday it would collapse, dissolve, or be remade. To speak of ancient myths and prophecies is to step into a realm where poetry, religion, and survival blended into visions of cosmic drama. These stories were not merely superstition. They were ways of asking timeless questions about mortality, change, and renewal. The Norse vision of Ragnarok is perhaps one of the most vivid apocalyptic myths. Born in the frozen north, where winters were long and unforgiving, this myth imagined the world consumed by fire and ice alike. At Ragnarok, the great serpent Jörmungandr would rise from the sea, giants would march across the rainbow bridge, and gods themselves would fall in battle. The sun would darken, stars would vanish, and the earth would be swallowed by chaos. Yet even in this destruction, there was the seed of renewal. Out of the ash and the sea, a new world would arise, green and fertile, waiting for survivors to begin again. This duality, death followed by rebirth, reflected not just mythic imagination, but the rhythms of the natural world, where long winters gave way to spring, and fields once blackened by fire could sprout again. In the Near East, biblical prophecies carried their own imagery of the end. The Book of Revelation, written in a time of Roman oppression, imagined horsemen, trumpets, and a final reckoning. To many readers across centuries, this text has seemed terrifying, filled with beasts, plagues, and judgment. Yet it is also deeply symbolic, using metaphor and vision to communicate hope that injustice would not endure forever. For early Christian communities, the apocalypse was not simply about the end of time, but about the promise of transformation, the collapse of corrupt empires, and the dawn of a just kingdom. In this sense, prophecy was not despair, but resilience, a reminder that suffering was temporary and that even endings could carry seeds of redemption. The Mayan calendar offers another lens on apocalyptic thinking, though often misunderstood. Popular imagination once seized on the date December 21st, 2012, interpreting it as a prophecy of global annihilation. In truth, the Mayan long count calendar simply marked the end of one great cycle and the beginning of another. For the Maya, time was not linear, but cyclical, and endings were never final. Just as the sun set each day and returned the next, epochs closed so that new ones could open. This idea of renewal echoes across many ancient traditions. Destruction is not a curtain falling, but a turning of the page. Greek myths, too, reflected concern with cosmic endings. Hesiod wrote of successive ages of humanity, the Golden Age, the Silver Age, the Bronze Age, and the Iron Age, each one less pure than the last. The implication was that human society would decline until the gods intervened, or until chaos reclaimed order. These myths mirrored human experience of war, famine, and decline, translating hardship into cosmic patterns. Even the flood myths found in Greece, Mesopotamia, and the Hebrew Bible point to a recurring theme. When corruption grows too great, waters rise to wash the slate clean, and a new humanity emerges with lessons to learn. In Hindu cosmology, time unfolds in immense cycles called yugas. The present age, Kali Yuga, is described as one of decline, where truth and virtue wane and strife grows. Yet this cycle too is destined to end, not as permanent destruction, but as preparation for a new Satya Yuga, a golden age of renewal. The concept stretches across billions of years, placing human life within cosmic cycles far larger than any empire or dynasty. It is a striking reminder that for many cultures, the end is never truly final, but part of a grander rhythm of birth, decay, and rebirth. In Islamic tradition, the Day of Judgment holds central place. The Quran describes signs of the end times, natural upheavals, moral decay, and the resurrection of the dead. Yet, within this vision is not only fear, but justice, a belief that wrongs would be made right, and that human actions matter in the ultimate accounting. Prophecies about the Mahdi, a redeemer figure, and the return of Jesus are woven into traditions across centuries. These narratives, like those of Christianity and Judaism, emphasize not only destruction, but also restoration and divine order. Indigenous traditions across the world also speak of endings and renewals. Some North American tribes tell of great floods or fires that reshaped the land. Aboriginal Australian stories speak of dreamtime cycles where the world is continually created and recreated. In Polynesian myths, gods reshape islands after cataclysms, reflecting the lived reality of volcanic eruptions and rising seas. These myths are not simply about catastrophe, but about the resilience of communities who lived close to nature's volatility. They carried lessons about respect for the land, warnings against imbalance, and hope that even after loss, life could flourish again. What unites these diverse myths and prophecies is a shared recognition of impermanence. Ancient people may not have spoken in the language of astrophysics or geology, but they observed the fragility of life. Crops failed, rivers flooded, plagues spread, and empires fell. To make sense of these realities, they told stories where the whole world itself could end. By placing catastrophe into a larger cosmic narrative, they gave meaning to suffering and offered reassurance that destruction was not senseless, but part of a cycle that could lead to renewal. It is important to see these myths not as outdated curiosities, but as cultural mirrors. They reveal how deeply human beings have always grappled with the possibility of endings. When the Norse told of Ragnarok, they were wrestling with the harshness of their environment. When the Hebrew prophets spoke of judgment, they were responding to exile, oppression, and longing for justice. When the Maya marked great cycles of time, they were capturing the patterns of the sky and the earth. Each myth arose from the real fears and observations of a people, dressed in the language of gods and symbols. Modern science has replaced many of these mythic images with natural explanations. Asteroids instead of angry deities, climate systems instead of divine punishment, stellar life cycles instead of cosmic beasts. Yet the impulse remains the same. We still ask, how does it end? What forces are too great for us to control? How do we live in the face of impermanence? Myth and prophecy framed these questions with dragons, floods, and fire. Science frames them with data, models, and probabilities. But the core is identical. Endings remind us that life is precious, temporary, and interconnected with forces beyond our control. Even today, echoes of ancient prophecy ripple through modern culture. Popular films borrow imagery from Revelation, video games invoke Ragnarok, and doomsday predictions often resurface whenever a comet passes close by. The Mayan calendar, misunderstood though it was, captured global attention because it tapped into something deeply human. Fascination with closure, with the final chapter of a story. These myths endure because they speak to something more than destruction. They remind us that in every ending, people seek meaning, order, and even hope. Approaching these myths with respect allows us to see them not as wrong science, but as profound art. They gave shape to fears and resilience at a time when little else was understood. They offered a framework for communities to process disaster and imagine renewal. And in their own way, they prepared humanity to eventually seek answers in science. The awe once reserved for gods battling at the end of time is not so different from the awe we feel when we learn about supernovae or black holes. The symbols have changed, but the wonder remains. As we move forward into scientific visions of endings, asteroids, climate collapse, nuclear risks, it is important to carry this lesson from myth. Fear alone is never the full story. Even in the harshest images of destruction, from Ragnarok's flames to Revelation's horsemen, there is a promise of renewal, of justice, of a dawn beyond the darkness. The ancients understood something we must not forget, that endings, real or imagined, can teach us how to live with greater care, gratitude, and responsibility. So when we ask how the world will end, it is worth remembering how humans have always asked this question. From icy northern sagas to desert prophecies, from temple calendars to dreamtime cycles, the story of endings is as old as humanity itself. Each vision, though shaped by culture and era, points us back to the same truth. Life is fragile, time is precious, and even in imagining destruction, we are really expressing our longing for renewal. The night sky looks peaceful when we gaze at it, a dome of quiet stars shining with steady light. Yet behind that calm glitter lies a universe alive with violence, energy, and constant transformation. Stars explode, galaxies collide, black holes swallow entire systems, and invisible radiation streams across space at nearly the speed of light. For us, here on Earth, the sky can feel distant, untouchable, and eternal. But the truth is that cosmic events have shaped life on this planet many times before, and they will again. The universe is fragile, and we live in its fragile corner. To think about cosmic fragility is to acknowledge that life on Earth depends on a balance of forces so delicate that even a single asteroid, one gamma-ray burst, or a nearby supernova could shift everything we know in an instant. The most familiar of these cosmic threats is the asteroid impact. Unlike the abstract scale of billions of years, asteroids feel tangible, almost cinematic, because Earth has been hit before. 66 million years ago, a space rock about 10 kilometers wide slammed into what is now the Yucatan Peninsula. The impact released energy equal to billions of nuclear bombs, carved out the Chicxulub crater, and triggered global chaos. Forests burned, skies darkened under ash, and the climate cooled. Dinosaurs, who had ruled Earth for more than 160 million years, disappeared almost overnight. Mammals survived, eventually giving rise to us. But the message was clear. A single rock from space can rewrite the story of life. Smaller asteroids hit Earth all the time, most burning up harmlessly in the atmosphere as meteors. Every so often, though, a larger one makes it through. In 1908, the Tunguska event flattened 80 million trees in Siberia when a space object exploded in the air. More recently, in 2013, a meteor exploded over Chelyabinsk, shattering windows and injuring over 1,000 people. These were not extinction-level events, but they were reminders that cosmic roulette never stops spinning. Astronomers track thousands of near-Earth objects, mapping their orbits to predict potential collisions. Most pose no danger, but the possibility of a large impact in the future remains real. Cosmic fragility is written into every orbit, yet asteroids are not the only celestial hazards. Far more terrifying in their raw power are gamma-ray bursts. These bursts are the most energetic explosions known in the universe, caused when massive stars collapse into black holes or when two neutron stars collide. For a few seconds, they unleash more energy than our Sun will emit in its entire 10 billion-year life. If one such burst were to occur within a few thousand light-years of Earth and its beam happened to point in our direction, the effects could be devastating. High-energy radiation could strip away the ozone layer, exposing the surface to harmful ultraviolet light. Ecosystems could collapse as plankton in the oceans died, disrupting the base of the food chain. While the probability of such a nearby event is low, The scale of its consequences makes it a sobering reminder of cosmic fragility. The universe is filled with fireworks, and sometimes we are directly in their line of sight. Supernovae offer another path to cosmic endings. When a massive star runs out of fuel, it collapses under its own gravity and then explodes outward with titanic force. The blast forges heavy elements like iron, gold, and uranium, scattering them across space. In fact, much of the material in our own bodies, the iron in our blood, the calcium in our bones, was created in ancient supernovae. These explosions are both creators and destroyers. If a supernova occurred within a certain distance of Earth, the intense radiation and shock waves could damage the atmosphere, alter climate, and potentially trigger mass extinctions. Astronomers keep watch on stars like Betelgeuse, a red supergiant nearing the end of its life. While its eventual explosion will be a spectacular sight, it is far enough away not to threaten Earth. Still, the idea that stars can die with such force that entire planets are scorched reminds us of how small we truly are beneath the cosmic canopy. There are also more subtle dangers hidden in the machinery of the cosmos. The Sun itself, though stable now, emits occasional solar storms and flares. These are not extinction-level threats, but they can disrupt satellites, power grids, and communication systems on which modern life depends. A solar superstorm like the one recorded in 1859, known as the Carrington event, could today knock out global electricity and digital networks for months. For a civilization reliant on technology, this too would feel like a kind of ending. Fragility is not only in fireballs from the sky, but in the quiet reliance we place on cosmic steadiness. Cosmic fragility extends to orbits and gravitational balances as well. Earth spins in a zone known as the habitable zone, where water can remain liquid and life as we know it can thrive. A small shift in orbit, a pull from another planet, or a long-term wobble in Earth's tilt can alter climate patterns dramatically. These cycles, known as Milankovitch cycles, have already driven ice ages and warm periods in Earth's history. On grander scales, entire star systems can be destabilized by passing stars or galactic tides. Life exists in a narrow window of balance, and the universe offers no guarantee that balance will last forever. Even black holes, those mysterious objects where gravity becomes so strong that not even light can escape, remind us of cosmic vulnerability. Thankfully, no black hole lurks close enough to Earth to swallow us whole. Yet if one were to drift into the neighborhood, its gravitational pull could disrupt planetary orbits, sling asteroids toward Earth, or even tear the solar system apart. While the likelihood is small, the thought underscores the fragility of our cosmic home. We live in a solar system where the planets move in a delicate dance, and a single intruder could throw the steps into chaos. The idea of cosmic fragility might sound overwhelming, but it is also strangely grounding. These vast forces remind us that life exists within a rare and delicate pocket of stability. Earth has survived countless asteroid impacts, solar storms, and cosmic events across 4.5 billion years. That resilience does not erase fragility, but it does highlight the extraordinary balance that makes life possible. When we think about cosmic threats, we are really thinking about how extraordinary it is that we are still here, breathing under a quiet sky filled with stars. Ancient myths once told of gods battling in the heavens, thunderbolts hurled to destroy the world, or cosmic serpents rising from the sea. In their own symbolic way, these stories reflected the same awareness of fragility. Today, science gives us different names and mechanisms: asteroids instead of serpents, gamma-ray bursts instead of divine judgment. But the feeling is the same. The cosmos is beautiful, but it is not always gentle. To survive here is to live with the knowledge that the sky is not merely decoration, but an active, changing, sometimes dangerous arena. And yet, within this awareness lies perspective. Most of the cosmic threats we describe occur on timescales so long and probabilities so low that they do not hang over our daily lives. The odds of a gamma-ray burst pointing directly at Earth in the next million years are vanishingly small. The Sun will not run out of fuel for another 5 billion years. Betelgeuse's supernova will be spectacular, but not dangerous. Asteroid impacts are the most immediate concern, but even there, global monitoring and potential deflection technologies give us tools for prevention. Fragility does not mean inevitability. To know the risks is also to know how rare survival already is, and how precious each ordinary day becomes in light of that rarity. When we step outside and see the stars, we are not just looking at distant suns. We are looking at history written in light, at reminders of cycles of birth and death far greater than our own. Every atom in our bodies once belonged to stars that lived and died long before Earth was born. Cosmic fragility does not only speak of endings, it also tells the story of how beginnings are made. The very forces that could someday threaten life are the same forces that made life possible. Supernovae forged the heavy elements we need. Asteroids may have delivered the first water and organic molecules to Earth. The universe, in its fragility, is both destroyer and creator. Perhaps that is the final lesson of cosmic fragility. Not to live in fear, but to live in awe. We occupy a small blue planet in a vast, restless universe. The threats are real, but they are also reminders of how rare and resilient life is. To imagine asteroid impacts or gamma-ray bursts is to confront how easily life could vanish. To look up at the stars tonight, knowing this, is to feel gratitude for the improbable balance that allows us to breathe, to speak, to wonder. The end of the world may one day come from the sky, but in the meantime, the sky also gives us perspective, beauty, and a reminder to hold life with care. The night sky looks calm when you step outside, but the universe has never been a place of stillness. It is alive with motion, gravity, and energy on scales so immense that our daily lives barely register as a ripple against them. The stars shine steadily, the planets move in their predictable paths, and the moon rises and sets with comforting rhythm, yet hidden in that order is a reality of fragility. Earth is part of a cosmic system where great events can unfold without warning, events that have happened before and will certainly happen again. To think about the end of the world in cosmic terms is to acknowledge that humanity lives at the mercy of forces beyond our control. The universe has created us, but it can also erase us in an instant. Asteroids are perhaps the most familiar cosmic threat because their evidence lies beneath our feet. Craters pockmark the surface of the moon, and Earth bears scars too, though erosion and weather often soften them with time. The Chicxulub crater in Mexico tells the most famous story. 66 million years ago, a space rock about 10 kilometers wide struck Earth with unimaginable force. In the aftermath, skies darkened with dust, global temperatures plunged, and ecosystems collapsed. The dinosaurs, which had thrived for millions of years, disappeared almost overnight. Their reign ended by something far beyond their ability to anticipate. That impact is not just history, it is a reminder. Smaller meteors streak through the atmosphere all the time, burning into brilliant fireballs. Some reach the ground. The Tunguska event in 1908 flattened millions of trees in Siberia. The Chelyabinsk meteor in 2013 shattered windows and injured more than 1,000 people with shockwaves alone. While most near-Earth asteroids pose no immediate danger, astronomers track them constantly because one day another large one could cross our path. What makes asteroids a particularly chilling example of cosmic fragility is the randomness. They are not personal, not targeted, simply debris left from the birth of the solar system still orbiting in vast swarms. Earth is struck all the time, though the size of the impact varies. Humanity now has telescopes and observatories scanning the skies, space missions mapping potential hazards, and even plans for deflection systems. But the underlying truth remains. The same kind of object that once cleared the path for mammals to thrive could appear again. The difference is that this time it would be our civilization forced to reckon with the aftermath. Beyond asteroids, there are more exotic dangers that stretch imagination. Gamma-ray bursts are among the most violent events the universe produces. These bursts occur when massive stars collapse into black holes, or when two neutron stars collide, releasing a jet of energy so powerful that in a few seconds it can outshine entire galaxies. If such a burst were aimed directly at Earth from a relatively close distance in cosmic terms, the results could be devastating. Radiation would strip the ozone layer, exposing the surface to harmful ultraviolet rays from the sun. Food chains could collapse, climates could shift, and life as we know it would be forced into a struggle for survival. The odds of such a burst pointing at us are very low, but the fact that it is even possible illustrates how delicate our existence truly is. Space does not need to send an asteroid our way to remind us of vulnerability. It can simply fire an invisible beam across the galaxy and change everything. Supernovae are another chapter in this story of cosmic fragility. A supernova is the explosive death of a massive star. When a star exhausts its nuclear fuel, gravity causes it to collapse, and the rebound creates a blast of unimaginable magnitude. Supernovae are both destructive and creative. They scatter heavy elements across the galaxy, the very elements that make up our own bodies. The iron in our blood, the calcium in our bones, the oxygen we breathe. All of these were forged in stellar furnaces and released during explosions billions of years ago. Yet, if a supernova were to occur within about 30 light-years of Earth, it could have catastrophic consequences. Radiation could disrupt the atmosphere, altering climate and biology. Scientists often point to Betelgeuse, a red supergiant star in Orion, which is nearing the end of its life. When it does explode, it will be spectacular to watch from Earth, brighter than the Moon, but fortunately far enough away not to harm us. Still, its inevitable death is a reminder that stars, like all things, have lifespans, and the universe reshapes itself through cycles of creation and destruction. Closer to home, the sun itself is a source of fragility. It is steady now, providing warmth and light, but even stars like ours are not perfectly constant. Solar flares and coronal mass ejections release bursts of charged particles that can strike Earth. In 1859, the Carrington event disrupted telegraph systems and created auroras visible as far south as the Caribbean. If such a solar storm occurred today, it could cripple satellites, disrupt power grids, and damage communication systems worldwide. It would not wipe out humanity, but it would test the resilience of our interconnected technology-dependent society. The sun, which sustains us, also reminds us that fragility lies not only in destruction of life, but in disruption of the systems we build. Cosmic fragility extends even further into the structure of the solar system itself. Earth orbits in a delicate zone where water can remain liquid and life can thrive. Small changes in orbit or tilt have triggered ice ages and warm periods. Larger disturbances, like the gravitational pull of a wandering star or a rogue planet passing nearby, could destabilize planetary paths altogether. These scenarios are rare, but in a galaxy filled with stars, movements over millions of years are inevitable. The balance of gravity that feels so permanent is in reality a constant negotiation, and Earth's habitability is a product of that fragile harmony. Black holes, with their gravity so intense that not even light can escape, are the universe's ultimate symbol of destructive potential. While none lurk dangerously close to Earth, the idea of such an object wandering into the solar system underscores fragility on a cosmic scale. A passing black hole could distort orbits, slingshot planets into interstellar space, or drag matter into its event horizon. Though unlikely, it illustrates again the theme that life depends on balance. Earth is safe not because the universe is gentle, but because by chance we live in a relatively calm corner of it, for now. Yet there is another side to this fragility, a perspective that softens fear with awe. The same events that threaten life also make life possible. Without asteroid impacts delivering water and organic molecules, Earth might never have become habitable. Without supernovae scattering elements, our bodies would not exist. Even the sun's storms produce auroras that paint the sky with shimmering light. Fragility does not mean futility. It means that existence is rare, precious, and born from the very processes that could one day erase it. To live with this awareness is not to despair, but to appreciate. Cosmic fragility teaches humility. It reminds us that human conflicts, however consuming, play out on a planet that spins in a galaxy filled with forces far larger than us. It also inspires gratitude. Every quiet evening, every sunrise, every ordinary breath is possible because for now, no asteroid is on collision course, no gamma-ray burst is aimed at us, no nearby star is collapsing into fire. Fragility is not only about endings, it is also about the extraordinary stretch of stability that has allowed life to flourish. Myth and science meet here. Ancient peoples told of dragons in the sky, gods waging war, or cosmic beasts devouring the world. Today we tell of asteroids, radiation bursts, and supernovae. The language has changed, but the awe is the same. We are creatures who look upward and see both wonder and danger. We have always sensed that the universe is powerful and that our place within it is temporary. Cosmic fragility is not a reason to live in fear, but a reason to live with reverence. The end of the world could come from space, but so too does life's beginning. We are made of stardust, forged in explosions, assembled in the chemistry of planets, and sustained by the light of a star. To understand fragility is to recognize that we are part of a larger cycle, born from destruction, capable of awareness, and perhaps able to prepare in small ways for what might come. Earth may one day face an asteroid or a cosmic burst, but until then, the sky remains our greatest teacher. It shows us that endings are woven into beginnings and that the fragility of life is matched only by its resilience. The sun has always been our most reliable companion. Every dawn it rises, every evening it sets, casting light and warmth across the face of Earth. Without it, there would be no life, no food, no breath. Plants transform its energy into sugars that feed ecosystems. Animals depend on the cycles of day and night that the sun creates. Our own bodies set their internal rhythms by its glow. In a very real way, the sun is not only a star in the sky, but the heartbeat of everything alive on this planet. Its gravity keeps Earth steady in orbit. Its light powers the climate system. Its warmth makes oceans liquid instead of frozen. And yet, the very same sun that nurtures us carries within itself the seeds of our eventual undoing. To understand cosmic fragility is to understand not only distant supernovae or asteroids, but the long, patient fate of our own star, the star of life that may one day become the star of death. The sun, like every star, is a furnace. At its core, temperatures reach 15 million degrees Celsius. Under such extreme pressure, hydrogen atoms collide and fuse into helium, releasing enormous amounts of energy. This nuclear fusion is what keeps the sun shining, and the balance between outward radiation and inward gravity is what keeps it stable. For 4.5 billion years, this balance has held, creating the conditions in which Earth could host life. But fusion cannot continue forever. Hydrogen fuel is finite, and the sun is already halfway through its lifespan. In another 5 billion years or so, the hydrogen in its core will run low. When that happens, the balance will tip. Gravity will begin to squeeze harder, and the sun will change into something new. For us, 5 billion years is an almost unimaginable time. Civilizations rise and fall in mere centuries. Species emerge and disappear in millions of years. The sun's lifespan stretches far beyond human history, but science allows us to look ahead across those eons with remarkable clarity. We can trace the stages of stellar evolution, not because we have lived them, but because we see them in the night sky. Red giants, white dwarfs, and nebulae show us what happens when stars age. The sun is ordinary, but that ordinariness gives us insight into its destiny. Its fate will mirror countless others across the galaxy. As hydrogen depletes, the sun's core will contract and heat up. Hydrogen fusion will continue in shells surrounding the core, while the core itself begins to prepare for helium fusion. This process causes the outer layers of the sun to expand dramatically. What was once a stable yellow star will swell into a red giant, hundreds of times larger in diameter. Earth, from its fragile position, will be caught in the middle of this transformation. The sun's brightness will increase, and with that brightness will come heat. Long before the red giant phase, within about 1 billion years, the sun will grow bright enough to trigger catastrophic warming on Earth. Oceans will evaporate, water vapor will amplify greenhouse effects, and the stable climate that nurtures life will vanish. That means the true end of Earth's habitability may arrive far earlier than the sun's final stages. Even though the sun itself may survive billions of years more, our window for life could close much sooner. Scientists predict that in 1 to 2 billion years, surface conditions will grow too extreme for complex life. Microbes might linger in sheltered places, but forests, oceans, and animals as we know them will fade away. In cosmic terms, the sun's gift of life is temporary, a lease that eventually expires. The thought can feel sobering, but it also highlights how extraordinary it is that we exist in this perfect slice of time. When the sun does reach its red giant stage, Earth's fate becomes even more precarious. As the star swells, it will likely engulf Mercury and Venus completely. Earth sits on the edge of possibility. Some models suggest our planet could be swallowed as well, consumed by plasma and fire. Other models hint that Earth may just escape, its orbit expanding outward as the sun loses mass. Yet even if Earth avoids total engulfment, the transformation will strip away the atmosphere, boil the oceans, and bake the crust. Life, in any form we recognize, will be impossible. Our blue planet will become a dry, scorched husk under a swollen red star. After this violent phase, the sun will shed its outer layers into space, forming a glowing planetary nebula. What remains at the center will no longer be a shining furnace, but a white dwarf, a dense stellar ember about the size of Earth, yet with half the sun's mass. This white dwarf will slowly cool for trillions of years, fading into darkness. The solar system, as we know it, will end not with an explosion, but with a slow dimming. Earth, if it survives physically, will orbit a corpse of a star, frozen and silent. The star that once gave life will linger as a memory in the form of a faint spark. This long narrative of the sun's future can stir fear, but it can also stir perspective. Human beings often think in terms of generations or centuries, but the sun reminds us of scales much larger. We are alive in a golden age, billions of years into the sun's life, but still billions of years before its death. We live in a pocket of stability where temperatures are just right, oceans are deep and alive, and the rhythms of day and night are dependable. To know that this balance will one day shift is not to diminish its value, but to deepen it. Fragility sharpens appreciation. Every morning sunrise is temporary, but that temporariness is what makes it precious. From another angle, the sun's eventual death is not merely an ending. It is also part of the greater cycle of cosmic recycling. The gas and dust the sun sheds in its red giant stage will enrich interstellar space. That material could someday become part of new stars, new planets, perhaps even new life. Just as our bodies contain atoms forged in past supernovae, future beings may carry atoms once part of our sun. The star of life may one day become the seed for other lives in corners of the galaxy we will never see. In this way, even the sun's death becomes a kind of continuation, a handoff of cosmic material across generations of stars. Our awareness of the sun's fate also shapes imagination and ambition. Knowing that Earth has a limited window has inspired thoughts of planetary migration and interstellar travel. While the timescales are immense, the principle is clear. Survival may one day depend on moving beyond our solar system. Cosmic fragility, when understood deeply, becomes not just a story of vulnerability, but of motivation. It reminds us that while we cannot alter the sun's destiny, we can prepare for our own. Life is resilient and adaptable. Perhaps in the distant future, the descendants of humanity or whatever life emerges after us will look up at a swollen red sun and know it is time to move on. The sun's dual role as giver and taker of life has always resonated in human culture. Ancient civilizations worshipped it as a god, built monuments aligned to its rising, and told stories about its eternal journey across the sky. Today we understand it through physics and astronomy, but the reverence remains. We know it as a sphere of plasma sustained by nuclear fusion, but we still marvel at its warmth and light. The more we learn about its fate, the more profound its daily presence feels. Every sunbeam is not just light. It is a gift from a process that will one day change, a reminder that we live in a moment between beginnings and endings. Cosmic fragility does not only lie in sudden catastrophes like asteroids or gamma-ray bursts, it also lies in the slow inevitabilities written into the very stars. The sun is steady now, but it carries within it the clockwork of its own transformation. Its end will not come tomorrow, nor in the lifetime of our species as it currently stands, but it will come. To know that is to live with humility, to realize that even our brightest light is temporary. But it is also to live with wonder, to recognize that fragility does not erase beauty. If anything, it makes beauty shine brighter. The sun's story is ultimately our story. From its birth clouds to its eventual death, it defines the window in which Earth is habitable. It shapes every breath, every heartbeat, every moment of history. Someday, its swelling will end that chapter, but until then, it is the guardian of life. The star of life will one day become the star of death, but in between, it gives us everything. The challenge for us is not to mourn that future, but to cherish the present, to marvel at the balance, and to live fully in the fleeting gift of light. The sun has always been our most reliable companion. Every dawn it rises, every evening it sets, casting light and warmth across the face of Earth. Without it, there would be no life, no food, no breath. Plants transform its energy into sugars that feed ecosystems. Animals depend on the cycles of day and night that the sun creates. Our own bodies set their internal rhythms by its glow. In a very real way, the sun is not only a star in the sky, but the heartbeat of everything alive on this planet. Its gravity keeps Earth steady in orbit. Its light powers the climate system. Its warmth makes oceans liquid instead of frozen. And yet, the very same sun that nurtures us carries within itself the seeds of our eventual undoing. To understand cosmic fragility is to understand not only distant supernovae or asteroids, but the long, patient fate of our own star, the star of life that may one day become the star of death. The sun, like every star, is a furnace. At its core, temperatures reach 15 million degrees Celsius. Under such extreme pressure, hydrogen atoms collide and fuse into helium, releasing enormous amounts of energy. This nuclear fusion is what keeps the sun shining, and the balance between outward radiation and inward gravity is what keeps it stable. For 4.5 billion years, this balance has held, creating the conditions in which Earth could host life. But fusion cannot continue forever. Hydrogen fuel is finite, and the Sun is already halfway through its lifespan. In another 5 billion years or so, the hydrogen in its core will run low. When that happens, the balance will tip. Gravity will begin to squeeze harder, and the Sun will change into something new. For us, 5 billion years is an almost unimaginable time. Civilizations rise and fall in mere centuries. Species emerge and disappear in millions of years. The Sun's lifespan stretches far beyond human history, but science allows us to look ahead across those eons with remarkable clarity. We can trace the stages of stellar evolution not because we have lived them, but because we see them in the night sky. Red giants, white dwarfs, and nebulae show us what happens when stars age. The Sun is ordinary, but that ordinariness gives us insight into its destiny. Its fate will mirror countless others across the galaxy. As hydrogen depletes, the Sun's core will contract and heat up. Hydrogen fusion will continue in shells surrounding the core, while the core itself begins to prepare for helium fusion. This process causes the outer layers of the Sun to expand dramatically. What was once a stable yellow star will swell into a red giant, hundreds of times larger in diameter. Earth, from its fragile position, will be caught in the middle of this transformation. The Sun's brightness will increase, and with that brightness will come heat. Long before the red giant phase, within about 1 billion years, the Sun will grow bright enough to trigger catastrophic warming on Earth. Oceans will evaporate, water vapor will amplify greenhouse effects, and the stable climate that nurtures life will vanish. That means the true end of Earth's habitability may arrive far earlier than the Sun's final stages. Even though the Sun itself may survive billions of years more, our window for life could close much sooner. Scientists predict that in 1 to 2 billion years, surface conditions will grow too extreme for complex life. Microbes might linger in sheltered places, but forests, oceans, and animals as we know them will fade away. In cosmic terms, the Sun's gift of life is temporary, a lease that eventually expires. The thought can feel sobering, but it also highlights how extraordinary it is that we exist in this perfect slice of time. When the Sun does reach its red giant stage, Earth's fate becomes even more precarious. As the star swells, it will likely engulf Mercury and Venus completely. Earth sits on the edge of possibility. Some models suggest our planet could be swallowed as well, consumed by plasma and fire. Other models hint that Earth may just escape, its orbit expanding outward as the Sun loses mass. Yet even if Earth avoids total engulfment, the transformation will strip away the atmosphere, boil the oceans, and bake the crust. Life, in any form we recognize, will be impossible. Our blue planet will become a dry, scorched husk under a swollen red star. After this violent phase, the Sun will shed its outer layers into space, forming a glowing planetary nebula. What remains at the center will no longer be a shining furnace, but a white dwarf, a dense, stellar ember about the size of Earth, yet with half the Sun's mass. This white dwarf will slowly cool for trillions of years, fading into darkness. The solar system as we know it will end not with an explosion but with a slow dimming. Earth, if it survives physically, will orbit a corpse of a star, frozen and silent. The star that once gave life will linger as a memory in the form of a faint spark. This long narrative of the Sun's future can stir fear, but it can also stir perspective. Human beings often think in terms of generations or centuries, but the Sun reminds us of scales much larger. We are alive in a golden age, billions of years into the Sun's life, but still billions of years before its death. We live in a pocket of stability where temperatures are just right, oceans are deep and alive, and the rhythms of day and night are dependable. To know that this balance will one day shift is not to diminish its value, but to deepen it. Fragility sharpens appreciation. Every morning sunrise is temporary, but that temporariness is what makes it precious. From another angle, the sun's eventual death is not merely an ending. It is also part of the greater cycle of cosmic recycling. The gas and dust the sun sheds in its red giant stage will enrich interstellar space. That material could someday become part of new stars, new planets, perhaps even new life. Just as our bodies contain atoms forged in past supernovae, future beings may carry atoms once part of our sun. The star of life may one day become the seed for other lives in corners of the galaxy we will never see. In this way, even the sun's death becomes a kind of continuation, a handoff of cosmic material across generations of stars. Our awareness of the sun's fate also shapes imagination and ambition. Knowing that Earth has a limited window has inspired thoughts of planetary migration and interstellar travel. While the timescales are immense, the principle is clear. Survival may one day depend on moving beyond our solar system. Cosmic fragility, when understood deeply, becomes not just a story of vulnerability, but of motivation. It reminds us that while we cannot alter the sun's destiny, we can prepare for our own. Life is resilient and adaptable. Perhaps, in the distant future, the descendants of humanity, or whatever life emerges after us, will look up at a swollen red sun and know it is time to move on. The sun's dual role as giver and taker of life has always resonated in human culture. Ancient civilizations worshipped it as a god, built monuments aligned to its rising, and told stories about its eternal journey across the sky. Today we understand it through physics and astronomy, but the reverence remains. We know it as a sphere of plasma sustained by nuclear fusion, but we still marvel at its warmth and light. The more we learn about its fate, the more profound its daily presence feels. Every sunbeam is not just light. It is a gift from a process that will one day change, a reminder that we live in a moment between beginnings and endings. Cosmic fragility does not only lie in sudden catastrophes like asteroids or gamma-ray bursts. It also lies in the slow inevitabilities written into the very stars. The sun is steady now, but it carries within it the clockwork of its own transformation. Its end will not come tomorrow, nor in the lifetime of our species as it currently stands, but it will come. To know that is to live with humility, to realize that even our brightest light is temporary. But it is also to live with wonder, to recognize that fragility does not erase beauty. If anything, it makes beauty shine brighter. The sun's story is ultimately our story. From its birth clouds to its eventual death, it defines the window in which Earth is habitable. It shapes every breath, every heartbeat, every moment of history. Someday its swelling will end that chapter, but until then, it is the guardian of life. The star of life will one day become the star of death, but in between, it gives us everything. The challenge for us is not to mourn that future, but to cherish the present, to marvel at the balance, and to live fully in the fleeting gift of light. Beneath our feet, the ground seems still, solid, and eternal. We build our homes on it, pave roads across it, plant crops in it, and trust that it will remain unmoving. Yet the earth is anything but still. The crust is fractured into plates that drift, collide, and dive beneath one another. Magma churns in hidden chambers, and faults silently store stress that can snap in an instant. Earthquakes and volcanoes remind us that the solid ground we rely on is, in truth, restless. And over spans of millions of years, this restlessness goes even further, rearranging continents, merging them into supercontinents, and tearing them apart again. To understand the end of the world, or at least the transformation of it, we must look downward into the dynamic planet that has always been both creator and destroyer of life. Earthquakes are among the most immediate demonstrations of this restlessness. In a matter of seconds, entire cities can tremble, buildings can crumble, and landscapes can shift. They occur because tectonic plates do not glide smoothly past one another. Instead, they catch, lock, and build up energy until the pressure is too great. Then they slip, releasing waves of motion that radiate through rock. The largest earthquakes can alter coastlines, raise mountains by meters, and generate tsunamis that race across oceans. History tells of quakes that destroyed ancient cities, toppled temples, and reshaped societies. Modern times tell the same story, with earthquakes in Japan, Chile, Turkey, and Haiti, showing how even the most prepared nations remain vulnerable. Technology helps us detect and measure, but no human system can stop the Earth from moving when it decides to move. Volcanoes are the other face of this geological power. While earthquakes release stored energy, volcanoes release stored matter. Beneath the crust, molten rock gathers in chambers until pressure builds high enough to break through. The result can be spectacular. A fountain of lava, clouds of ash rising into the sky, rivers of molten rock carving new landscapes. But volcanic eruptions are not just spectacles. They can be catastrophic. In 79 CE, Mount Vesuvius buried Pompeii under ash and pumice. In 1815, Mount Tambora's eruption in Indonesia caused the year without a summer, disrupting global agriculture and leading to famine. In 1883, Krakatoa's blast sent shockwaves around the world and darkened skies for months. Even smaller eruptions can ground plains, pollute air, and displace communities. Supervolcanoes represent the extreme end of this spectrum. Unlike regular volcanoes, which form distinct mountains, supervolcanoes lie in vast calderas that can release thousands of cubic kilometers of material in a single eruption. Yellowstone in the United States is one of the most famous examples. Its past eruptions reshaped continents and influenced climates across the globe. Scientists monitor it carefully, not because an eruption is expected soon, but because the potential consequences are immense. A supervolcano could blanket continents in ash, shut down agriculture for years, and cause widespread cooling by blocking sunlight. The fragility of modern civilization becomes clear when we imagine what such an eruption would mean for a world dependent on global food systems and interconnected economies. Yet earthquakes and volcanoes, for all their destructive power, are also engines of creation. Mountain ranges like the Himalayas exist because of tectonic collisions. Islands like Hawaii rise from volcanic hotspots in the ocean floor. Fertile soils rich in minerals come from volcanic ash that breaks down into nutrients. Earth's surface is not static. It is renewed by these very processes that sometimes devastate. Without them, continents would erode flat, nutrients would wash away, and life itself might lack the raw materials needed to thrive. The fragility of human structures contrasts with the resilience of the planet itself. We are temporary guests on a surface that is constantly recycling itself. On timescales longer than human history, tectonic forces go even further. Continents drift slowly but relentlessly, moving centimeters per year. Over tens of millions of years, these movements rearrange oceans and land masses into entirely new patterns. In the past, all land came together in the supercontinent Pangaea, which broke apart into the continents we know today. Before Pangaea, there were others, like Rodinia and Gondwana, each forming, breaking, and reforming in cycles. The next supercontinent is already on its way, though it may not arrive for another 200 to 300 million years. Some scientists predict that the Atlantic Ocean will close, bringing the Americas back toward Europe and Africa in a supercontinent they call Pangaea Proxima. Others envision a Pacific-centered supercontinent. Whatever form it takes, the rearrangement will reshape climates, ecosystems, and the very conditions for life. Supercontinents bring both opportunities and challenges. When land masses unite, interiors can become vast deserts, far from moderating ocean influences. Coastlines shrink, reducing habitats for marine ecosystems. Weather patterns shift, altering rainfall and temperatures. Past extinctions have been linked to supercontinent cycles, as ecosystems struggled to adapt to changing environments. At the same time, new mountains rise, fresh soils spread, and evolution finds new pathways. The end of the world for one set of species often becomes the beginning for another. Earth's geological restlessness ensures that stability is never permanent. What makes earthquakes, volcanoes, and supercontinents part of the story of how the world might end is not only their immediate destructive potential, but also their ability to change the trajectory of life itself. A massive quake or eruption could kill millions, displace billions, and alter global systems. Over deeper time, continental drift could transform the planet into a place far less hospitable to complex life. In the same way that past mass extinctions were linked to volcanic outpourings and tectonic shifts, future geological events could write the script of life's next great transformation, or its decline. The interplay between geology and climate deepens this fragility. Large eruptions release carbon dioxide and sulfur dioxide, gases that can either warm or cool the atmosphere. Flood basalt eruptions in Earth's past have been linked to catastrophic warming and mass extinction events. The Siberian Traps eruption 252 million years ago is believed to have triggered the Great Dying, the most severe extinction in Earth's history, wiping out around 90% of species. The Deccan Traps eruption may have played a role alongside the Chicxulub asteroid in ending the age of dinosaurs. These examples show how the forces beneath our feet can ripple outward into the sky, the oceans, and the very conditions of survival. Our modern civilization is especially vulnerable to these shifts. A supervolcano today would not simply disrupt local regions, but entire supply chains, food production systems, and climate stability. Earthquakes strike cities where millions live in high-rises, and even with strict building codes, the risk remains. Volcanoes erupt near travel hubs, grounding global flights. The geological forces that once shaped isolated landscapes now have global consequences, because humanity is everywhere, interconnected, and reliant on fragile systems. Still, perspective matters. The Earth has endured countless quakes, eruptions, and supercontinent cycles, and life has continued. Fragility does not mean inevitability of extinction. It means awareness of how much our world depends on balances that can shift suddenly or gradually. Earthquakes remind us of suddenness, volcanoes remind us of intensity, and supercontinents remind us of deep time. Together, they form a story of constant transformation. The end of the world may not come from a cosmic event crashing into us, but from the slow reshaping of the ground we stand on, or the sudden fury of it breaking open. At the same time, resilience is part of the story. Humans have always adapted. Ancient cities destroyed by quakes were rebuilt. Farmers returned to the slopes of volcanoes because the soil was rich. Communities learned to live with the ground's unpredictability. In that sense, geological fragility has always been part of the human story. It is both a threat and a teacher, reminding us that we live on a living planet, not a static one. The cycles of earthquakes, volcanoes, and supercontinents point to a broader truth. Endings and beginnings are not separate in Earth's history. They are intertwined. Every mountain that rises will one day erode. Every continent that splits will one day collide again. Every eruption that darkens the sky will one day fade into fertile fields. Fragility is not the absence of continuity. It is the rhythm of it. And in that rhythm, life has found ways to adapt, flourish, and endure, even as the surface beneath it shifts endlessly. The world as we know it will not last forever. Earthquakes will continue to jolt cities, volcanoes will continue to sculpt and scar the land, and continents will continue their slow dance toward new configurations. Whether these changes bring crisis or renewal depends on perspective and preparation. For us, they are reminders that permanence is an illusion. The ground is alive, and its motion will shape the story of life long after we are gone. To walk across Earth is to walk across a surface in motion, a reminder that stability is fleeting and that the end of the world may come not from above, but from below. The Earth's climate has never been still. It breathes across time, shifting between warmth and cold, between frozen silence and flourishing green. Long before humans recorded history, the planet cycled through ice ages that sculpted continents, carved valleys, and shaped the course of life. Glaciers advanced, oceans fell, and great sheets of ice covered much of the northern hemisphere. Then the ice retreated, temperatures rose, seas expanded, and forests spread across lands once barren. These cycles of ice and heat are part of the planet's deep rhythm, a dance of geology, atmosphere, and solar patterns. Yet today, for the first time, humanity finds itself a driver of change, accelerating warming with emissions and tipping balances that evolved over millions of years. The story of ice, heat, and climate collapse is both a history of what has come before and a warning of what may lie ahead if we ignore the signals etched into ice cores, tree rings, and ancient sediments. Ice ages have punctuated Earth's history many times. The most recent, often called the Pleistocene glaciation, began about 2.6 million years ago and ended only 12,000 years ago. During this long epoch, the planet shifted repeatedly between colder and warmer periods, driven by subtle changes in Earth's orbit around the Sun, known as Milankovitch cycles. These cycles altered the amount of solar energy reaching different parts of the globe, tipping the scales toward glaciation or thaw. When the ice expanded, it transformed the landscape. Sheets more than a mile thick pressed down on Canada, Scandinavia, and parts of northern Europe. The weight of the ice depressed continents, changing the shape of the land itself. Sea levels fell as water was locked into glaciers, exposing land bridges that allowed early humans to migrate from Asia into the Americas. Life adapted to these shifting boundaries, with species evolving to survive frigid climates and then retreating or disappearing as the warmth returned. The end of the last ice age set the stage for civilization. As the glaciers retreated, rivers carved out fertile valleys and seas flooded new coastlines. The stable climate of the Holocene, the epoch we still inhabit, provided reliable seasons for agriculture. Farming spread across Mesopotamia, the Nile, the Indus Valley, and beyond, giving rise to the great civilizations of history. This stability was unusual compared to the wild swings of earlier ages. For more than 10,000 years, temperatures varied within a narrow range, allowing crops to thrive, animals to be domesticated, and human societies to grow in complexity. The quiet of this climate stability has been the cradle of all that we know as human culture. Yet this stability is fragile, and history holds reminders of how quickly it can shift. Even within the Holocene, smaller climate events left their mark. The Younger Dryas, about 12,900 years ago, saw temperatures plunge for over 1,000 years, possibly triggered by a disruption in ocean currents. The medieval warm period, between the 9th and 14th centuries, brought milder conditions to Europe that aided agriculture. Then came the Little Ice Age, spanning the 14th to 19th centuries, when colder winters froze rivers like the Thames and altered harvests, contributing to famine and unrest. These fluctuations were modest compared to the Great Ice Ages, but they show how human societies have always been sensitive to the climate's pulse. A few degrees warmer or colder could change everything from where people lived to what they ate. Today, however, the story is different. The warming we face is not driven by orbital cycles or natural rhythms. It is driven by human activity, particularly the burning of fossil fuels that release carbon dioxide and methane into the atmosphere. These greenhouse gases trap heat, thickening the blanket that keeps Earth warm. Since the Industrial Revolution, concentrations of carbon dioxide have risen from about 280 parts per million to over 420 parts per million today, the highest in at least 800,000 years, and likely much longer. This rapid rise has pushed temperatures upward at a pace far faster than natural systems can adapt. The past century has seen an average increase of about 1.2 degrees Celsius, but the trend continues upward, and projections suggest we may reach 1.5 or even 2 degrees within the coming decades. At first glance, a degree or two may sound small, yet the climate system is delicate, and small shifts cascade into enormous consequences. Melting glaciers raise sea levels, threatening coastal cities from Miami to Jakarta. Warmer oceans intensify hurricanes and typhoons, fueling storms that bring devastation to millions. Droughts grow longer and harsher, straining food supplies and sparking migration. Wildfires spread more easily through parched forests, consuming homes and habitats. Coral reefs bleach and die, taking with them the ecosystems that depend on them. For those who study paleoclimate, the warning is clear. What we are doing in a century rivals what natural processes did over tens of thousands of years. The possibility of climate collapse becomes more tangible when we consider tipping points. These are thresholds in the Earth system beyond which change becomes self-reinforcing and difficult to stop. One such tipping point is the melting of Arctic sea ice. Ice reflects sunlight back into space, but as it melts, dark ocean water absorbs more heat, accelerating warming. Another is the thawing of permafrost in Siberia and Canada, which releases methane, a powerful greenhouse gas, creating a feedback loop. The Greenland ice sheet, if it melts entirely, could raise global sea levels by 7 meters. The collapse of the West Antarctic ice sheet could add several more. Ocean currents, such as the Atlantic meridional overturning circulation, could slow or stop, disrupting weather patterns across the globe. These are not far-off fantasies, but risks already being monitored with urgency. History shows that climate shifts can bring collapse to civilizations. The Akkadian Empire in Mesopotamia fell during a severe drought 4,200 years ago. The Maya civilization in Central America suffered repeated droughts that weakened its cities. The Norse settlements in Greenland disappeared when the Little Ice Age tightened its grip. These examples reveal that even modest climate changes can undermine societies, especially when combined with political or economic stress. Our global civilization, with billions of people and vast interdependence, faces risks on an unprecedented scale if warming continues unchecked. Yet the story is not only one of doom. Humanity has tools and knowledge our ancestors lacked. Renewable energy technologies, solar, wind, geothermal, offer pathways to reduce emissions. Advances in agriculture can make farming more resilient. Reforestation and carbon capture aim to restore balance. International agreements, like the Paris Climate Accord, attempt to unify nations toward a shared goal of limiting warming. Whether these efforts succeed depends on political will, technological innovation, and cultural shifts. The outcome is not predetermined. It is shaped by choices being made now. Ice and heat remind us of balance. Too much cold, and life struggles beneath glaciers. Too much heat, and ecosystems collapse under droughts and floods. The narrow band of stability that nurtured civilization is precious, and losing it would be like losing the rhythm of a heartbeat. But the fact that Earth has swung between extremes before also shows resilience. Life survived the great ice ages, adapted through warming epochs, and found ways to thrive again. The challenge now is whether humanity, with its global footprint, can adapt quickly enough to the changes it has unleashed. Climate collapse does not mean instant extinction, but it does mean transformation. Cities may need to retreat from coastlines. Farming may need to move northward or change entirely. Migration may become the story of millions. For future generations, the shape of daily life could be very different from what we know. Yet, within change, lies possibility. Communities may rediscover sustainable ways of living. New technologies may open doors to cleaner futures. The choices of the present carve the path of the future, determining whether we face crisis unprepared or navigate it with wisdom. The end of the world through ice or heat is not a sudden cataclysm like an asteroid impact. It is a slow reshaping, unfolding across decades and centuries, visible in melting glaciers, shifting seasons, and rising seas. To some it may feel less dramatic, but its consequences are profound. The story of ice ages teaches humility before the power of nature. The story of today's warming teaches responsibility for the power we now hold. Together, they invite us to see climate not as a backdrop, but as a living system we depend on and influence. As we look at the fragile balance between frozen and fiery extremes, one truth becomes clear. The Earth will endure. It has endured greater shifts before. The question is whether humanity can endure with it, whether we can learn to live within limits, to respect the thin line of stability that makes civilization possible. To face ice and heat is to face ourselves, to decide whether we are caretakers of balance or architects of collapse. The choice is still before us, but the time to make it grows shorter with each passing season. Throughout history, few forces have reminded humanity of its fragility as clearly as plagues and pandemics. Long before modern medicine, the spread of invisible pathogens could transform empires, collapse economies, and reshape cultures. Disease has been both a quiet constant and a dramatic disruptor, moving along trade routes, hiding in ships' holds, and surfacing in crowded marketplaces. The story of plagues is not only about death, but also about survival, adaptation, and the ways societies learn to respond. When we look back across centuries, the recurring theme is clear. Pandemics expose the delicate threads that bind communities together, forcing us to rethink health, safety, cooperation, and resilience. In exploring this history and its modern echoes, we find both caution and hope. The ancient world knew disease well. In Athens during the Peloponnesian War in 430 BCE, a plague struck the city while it was under siege. Crowded conditions, lack of sanitation, and limited medical knowledge meant the illness spread quickly, killing perhaps a third of the population. Historians believe it might have been typhoid fever, though the true cause remains uncertain. What mattered most to Athenians was not just the staggering loss of life, but the unraveling of social norms. Fear eroded trust, funerals became hurried, and civic pride faltered. The plague became a turning point in the city's fate, weakening its power and leaving a lesson for posterity. When health collapses, even strong societies can stagger. Centuries later, the most infamous pandemic in human memory left a scar still visible in history books: the Black Death of the 14th century. Bubonic plague, caused by the bacterium Yersinia pestis, spread from Central Asia to Europe through fleas carried by rats on merchant ships. It arrived in a Europe already strained by war and famine, and its impact was staggering. Between 1347 and 1351, an estimated one-third to one-half of Europe's population perished. Villages vanished, monasteries emptied, and cities buried their dead in mass graves. Yet even amid devastation, the pandemic sparked profound changes. Labor shortages empowered surviving workers to demand better conditions. Religious upheaval grew as people sought meaning in tragedy. The seeds of transformation were sown in the soil of crisis. The Black Death stands as a reminder of both vulnerability and unexpected renewal. Other pandemics followed. The 16th century saw smallpox carried by European colonists devastate indigenous populations in the Americas. With no prior exposure, entire communities were wiped out, altering the course of civilizations from the Aztec and Inca empires to countless smaller societies. The scale of mortality was so vast that some scholars argue it contributed to global climate effects. as depopulated farmland reforested and drew carbon dioxide out of the atmosphere, a chilling reminder of how deeply human presence shapes the planet. The 19th and early 20th centuries were marked by waves of cholera pandemics, spreading along new trade and travel networks as the industrial age connected cities across continents. Cholera's hallmark, violent diarrhea and dehydration, terrified populations and revealed the stark consequences of poor sanitation. Yet from tragedy came progress. The work of John Snow in London in 1854, tracing a cholera outbreak to a contaminated water pump, laid the foundations of modern epidemiology and public health. The response to cholera pandemics was not only medical, but infrastructural. Cities invested in clean water, sewage systems, and urban planning. Disease taught society to rethink the very design of civilization. The early 20th century brought another global crisis, the influenza pandemic of 1918 to 19. Known as the Spanish flu, though it did not originate in Spain, this virus infected an estimated 1/3 of the world's population and killed tens of millions, more than the casualties of World War I. What made it devastating was not just its speed, but its tendency to strike young, healthy adults with unusual severity. Entire communities were paralyzed, with schools, theaters, and factories shuttered. Medical science was still limited, and antibiotics to treat secondary infections did not yet exist. Yet this tragedy also highlighted the importance of global monitoring and cooperation. Nations began to see that diseases do not respect borders and that preparedness must be international. As the century unfolded, pandemics continued to remind humanity of its vulnerability. The emergence of HIV/AIDS in the 1980s brought a crisis unlike others. Slow-moving but relentless, it reshaped the world's understanding of viruses and stigma. At first, fear and discrimination overshadowed compassion, with marginalized communities facing both illness and social exclusion. Over time, activism, medical research, and international cooperation transformed HIV from a near-certain death sentence into a manageable chronic condition for millions with access to treatment. HIV/AIDS demonstrated how pandemics are not only biological phenomena, but also deeply social, entwined with politics, culture, and human rights. In the 21st century, the arrival of new pandemics proved that despite advances in medicine, the risks remain profound. SARS in 2003, though contained, showed how swiftly a coronavirus could spread. The H1N1 influenza pandemic of 2009 reminded the world that flu remains a constant threat. Then came COVID-19 in 2019 to 2020, the most disruptive global pandemic in a century. Originating as a novel coronavirus, it spread rapidly, overwhelming hospitals, straining supply chains, and altering daily life on a scale unprecedented in modern memory. Lockdowns, travel restrictions, and mask mandates became universal. Entire economies slowed, education moved online, and societies discovered both their interconnectedness and their fault lines. The COVID-19 pandemic also underscored the speed of scientific innovation. Vaccines were developed in record time, harnessing new technologies like mRNA. Yet access was uneven, exposing global inequality. The pandemic revealed how information, accurate or misleading, travels as fast as any virus, with social media amplifying both truth and conspiracy. It reminded the world that combating disease requires more than medicine. It requires trust, cooperation, and clear communication. Beyond natural emergence, another layer of concern has grown: the possibility of lab accidents or engineered pathogens. With biotechnology advancing rapidly, the same tools that offer hope for cures also carry risks of misuse or error. Debates about biosecurity emphasize the importance of oversight, transparency, and ethical responsibility. The fear is not science itself, but what might happen if precaution fails. As humanity wields more power over biology, it must balance innovation with safeguards. Pandemics also remind us of resilience. Time and again, humans have endured. Quarantine, vaccines, sanitation, and medical treatments have all emerged from crises. Societies adapt rituals, from new burial practices to virtual communication, proving flexibility in the face of upheaval. At the same time, pandemics highlight inequalities. The poor, the marginalized, and the vulnerable often suffer disproportionately, with less access to care or the ability to protect themselves. Recognizing this imbalance is part of building a more resilient global health system. Looking ahead, climate change and globalization intertwine with pandemic risk. Warmer temperatures expand the ranges of disease-carrying insects like mosquitoes, increasing the reach of malaria, dengue, and Zika virus. Deforestation and urbanization bring humans into closer contact with wildlife, raising the chances of zoonotic spillover events, where pathogens jump from animals to humans. Air travel connects cities in hours, meaning an outbreak in one corner of the world can become global within days. These realities make preparedness not optional, but essential. Surveillance systems, global cooperation, and investment in health infrastructure become humanity's defense against the unseen. Yet even as we imagine possible collapses, it is worth remembering that pandemics are not solely stories of destruction. They are also catalysts for progress. They teach humility in the face of nature's complexity. They highlight the importance of science and collective action. They remind us of the deep truth that no nation, no community, and no person stands apart from the global web of life. Just as pathogens move freely, so too must compassion and cooperation. The end of the world through plague is not inevitable, but the history of pandemics shows us how fragile normal life can be. In a matter of weeks, familiar rhythms can unravel, but it also shows us that endings can be resisted, that through preparation, solidarity, and knowledge, societies can weather storms. Each pandemic, from Athens to COVID-19, has left behind lessons written not in prophecy, but in lived experience. The challenge is whether humanity will remember those lessons before the next crisis arrives. The world may one day face another pandemic that rivals the Black Death or COVID-19 in scale. But whether it ends in collapse or recovery will depend not only on biology, but on choice. It will depend on whether global society values truth over rumor, equity over exclusion, and foresight over complacency. In this way, pandemics are mirrors. They show us both our vulnerabilities and our potential for resilience. To study them is not to invite fear, but to prepare with wisdom, to see that survival has always been about adaptation, cooperation, and the will to endure. From the very beginning of human history, survival has been bound to the land, the rivers, the forests, and the seas. Our ancestors rose and fell with harvests, prayed for rains, and built their settlements near water sources. Even today, in an age of satellites, skyscrapers, and global trade, human life is still anchored to soil fertility, fresh water, forests, and oceans. When these systems thrive, societies flourish. When they falter, famine, thirst, and ecological breakdown ripple through every layer of life. This truth has repeated across centuries, a constant reminder that civilization's foundations are not steel or concrete, but the fragile balance of the natural world. Famine is one of the oldest specters haunting humanity. In the ancient world, a bad harvest meant hunger and vulnerability. Crops failed with droughts, floods, or plagues of locusts. Even powerful empires could collapse when food ran short. In Egypt, the Nile's flooding was both a blessing and a curse. Too little water and the soil cracked. Too much and entire villages were swept away. When the river delivered just right, it fed a civilization. When it didn't, famine stalked the land. Similar cycles played out in Mesopotamia, China, and Mesoamerica, where food security was tethered to the mercy of weather and soil. Hunger was never just physical. It was social and political, shaping migrations, wars, and the rise and fall of dynasties. In the Middle Ages, Europe endured the Great Famine of 1315 to 1317. Cold, wet summers destroyed crops, livestock diseases spread, and millions suffered. Chroniclers recorded desperate measures, people eating bark, straw, even the flesh of animals unfit for consumption. The famine left bodies weakened, making the population more vulnerable to the Black Death a generation later. It was a stark lesson in how one ecological stress can cascade into another, with hunger weakening defenses against disease. Food shortages have never existed in isolation. They are threads in a wider web of vulnerability. Fast forward to the 20th century, and famine still shaped history. The Dust Bowl of the 1930s in the United States saw fertile soil literally blow away under the twin pressures of drought and poor farming practices. Entire communities abandoned their lands, migrating west in search of work and sustenance. In China, the Great Leap Forward famine of the late 1950s and early 1960s caused millions of deaths, triggered not only by drought, but also by political policies that disrupted food production and distribution. These examples remind us that famine is rarely a product of nature alone. Human choices about land use, governance, and distribution often decide whether scarcity turns into catastrophe. At the heart of food security lies soil. This thin layer of earth, built over millennia, holds the nutrients that sustain crops. Yet soil is fragile. Overfarming, deforestation, and erosion strip it away, while chemical overuse can degrade its fertility. Across the world, fertile topsoil is vanishing faster than it can regenerate. Without healthy soil, even the best seeds and technology cannot guarantee harvests. In places like sub-Saharan Africa and South Asia, where populations continue to grow, soil degradation threatens to lock communities in cycles of poverty and hunger. Protecting soil is protecting civilization itself, though it often goes unnoticed beneath our feet. Just as critical is water. Human bodies can survive weeks without food, but only days without clean water. Fresh water makes up a tiny fraction of the Earth's supply, and it is unevenly distributed. Rivers like the Nile, the Tigris-Euphrates, the Indus, and the Colorado sustain millions, but are now strained by overuse and climate change. Groundwater, stored in aquifers for centuries, is being pumped faster than it can be replenished, leaving some regions facing future scarcity. The Middle East, parts of India, and even areas of the United States confront the reality of wells running dry. Water scarcity is not simply a matter of thirst, it undermines agriculture, energy, and health. It can also ignite conflict as nations and communities vie for dwindling supplies. Forests, too, are more than just landscapes of trees. They regulate rainfall, anchor soil, and harbor biodiversity. They provide food, medicine, and fuel. Yet deforestation, driven by agriculture, logging, and urban expansion, has stripped vast areas. The Amazon rainforest, often called the lungs of the earth, is shrinking at an alarming pace. Its loss disrupts rainfall patterns, not only in South America, but also far beyond, affecting global climate. Forests act as carbon sinks, slowing climate change. But when cut down or burned, they release carbon back into the atmosphere. In losing forests, humanity loses not only beauty and biodiversity, but also one of the planet's key defense systems against ecological collapse. The oceans, covering more than 70% of Earth's surface, are equally vital. They regulate climate, produce oxygen, and feed billions. Yet they too are under strain. Overfishing depletes species faster than they can recover. Pollution, from plastics to oil spills, spreads toxins through marine food chains. Rising carbon dioxide levels cause acidification, weakening coral reefs and shellfish populations. Warming waters alter currents and devastate ecosystems. For coastal communities, the ocean's breakdown means both economic loss and rising danger, as sea levels climb and storms intensify. The sea that once symbolized abundance increasingly mirrors fragility. Ecological breakdown is rarely a single event. It is a chain reaction. Scarcity of food drives migration, migration can fuel conflict, and conflict deepens scarcity. Drought can destroy crops, but it also pushes herders and farmers into competition over shrinking pastures. When forests vanish, rivers dry, and fisheries collapse, the fallout is not measured only in statistics, but in disrupted families, lost traditions, and children facing hunger. Each ecological fracture widens social divides, disproportionately harming the poorest, who have the least capacity to adapt. Modern technology offers both hope and peril. Advances in agriculture, genetically modified crops, precision irrigation, synthetic fertilizers, have fed billions. Yet they also come with trade-offs: water overuse, pollution, and vulnerability to monocultures. Cities depend on global supply chains, meaning a drought in one region can ripple into higher food prices and shortages across continents. Globalization ties humanity together, making local ecological stress a global issue. In this sense, famine and ecological breakdown are no longer isolated tragedies, but shared risks. Climate change compounds these challenges. Rising temperatures intensify droughts in some regions, while triggering floods in others. Melting glaciers reduce long-term water supplies for billions who depend on river meltwater. Extreme weather events destroy harvests, disrupt fisheries, and damage infrastructure. Scientists warn of tipping points, moments when ecological systems shift irreversibly, such as the collapse of ice sheets or the dieback of rainforests. These changes do not unfold gradually. They can accelerate suddenly, leaving little time for adaptation. And yet, history also demonstrates resilience. Communities have learned to harvest rainwater, rotate crops, restore forests, and rebuild fisheries. Societies have recovered from droughts by diversifying food sources and creating grain reserves. Modern tools like desalination, renewable energy, and vertical farming hint at ways to lessen pressure on land and water. Ecological breakdown is not an inevitability. It is a possibility shaped by choices. Humanity stands at a crossroads, with the knowledge to mitigate risks, but also the temptation to delay action. When considering how the world might end, famine, water scarcity, and ecological breakdown remind us that collapse need not arrive in a dramatic instant. Sometimes it comes as a slow erosion of security, a gradual tightening of scarcity, a steady fraying of resilience. The danger lies in ignoring the signs until they become unavoidable. But the same story also contains seeds of hope. Human beings have the capacity to adapt, to innovate, and to rebuild. The challenge is whether we can act before crisis forces our hand. The soil, the rivers, the forests, and the seas remain our quiet companions, sustaining life day after day. Their fragility is our fragility. Their endurance is our endurance. To study famine and ecological breakdown is not to surrender to despair, but to acknowledge the truth that the end of abundance is possible, but so too is the renewal of balance. The future depends on how wisely humanity listens to the whispers of the earth and how gently it learns to walk upon it. When people speak about the end of the world, one of the images that often comes to mind is a mushroom cloud rising into the sky. Nuclear weapons are unique in history, tools of human invention that contain within them the capacity to erase entire cities in a heartbeat and perhaps bring about a chain of consequences capable of reshaping life across the planet. Unlike natural disasters, which strike without intent, nuclear catastrophe is a reminder that human hands can both build and destroy on unimaginable scales. To think calmly about this possibility is not to invite fear, but to acknowledge the responsibility of living in a world where such power exists. The nuclear age began in the crucible of World War II, when science, war, and politics converged in the Manhattan Project. The first atomic bombs dropped on Hiroshima and Nagasaki revealed both the immediate destructive capacity of nuclear fire and the long shadow of radiation. Buildings turned to rubble. Fires consumed entire neighborhoods, and survivors carried scars for generations. The bombs ended a war, but also opened an era of uncertainty. Humanity had unlocked energy hidden in the atom, but in doing so had unleashed the possibility of self-destruction. In the decades that followed, the world entered the Cold War, a period where nuclear weapons became the ultimate symbol of deterrence. The United States and the Soviet Union stockpiled tens of thousands of warheads, each capable of destroying entire regions. The doctrine of mutually assured destruction took hold, where the very threat of total annihilation was supposed to preserve peace. The paradox was chilling. Security was built not on safety, but on the assurance that any conflict could escalate into catastrophe. For generations, school children practiced duck and cover drills, families built fallout shelters, and governments crafted elaborate strategies for surviving the unthinkable. The weapons themselves became both invisible and omnipresent, woven into politics, culture, and the daily background of human life. Beyond the immediate blast of a nuclear explosion lies the insidious danger of fallout. When a bomb detonates, it lifts dust, debris, and radioactive particles high into the atmosphere. These particles then drift back to Earth, contaminating soil, water, and air. Fallout can travel hundreds or even thousands of miles from the original explosion, turning places untouched by fire into zones of invisible danger. Radiation sickness, cancers, genetic damage. These are the long-term legacies of exposure. Entire landscapes can become hazardous for generations, as seen in the aftermath of accidents like Chernobyl and Fukushima, though these were not weapons, but reactors. The principle is the same. Once radioactive particles are released, they weave into ecosystems and bodies alike. What makes nuclear conflict even more frightening is not only the direct destruction, but the indirect consequences. Scientists in the 1980s began to explore the idea of nuclear winter. If hundreds of bombs were detonated, the resulting firestorms in cities and forests could loft enormous amounts of soot and smoke into the upper atmosphere. Unlike ordinary smoke, which rains down quickly, these fine particles could linger for months or years, blocking sunlight across the globe. Crops would wither, temperatures would plummet, rainfall patterns would shift. Even countries far from the conflict zones would face famine, economic collapse, and mass migration. The apocalypse in this vision would not be fire alone, but cold and hunger spread across the world. The nuclear winter hypothesis is sobering because it reveals how fragile our global systems truly are. Agriculture depends on stable seasons and predictable sunlight. Disrupt those, and even the most advanced societies could stumble. A small nuclear exchange, perhaps between regional powers, might not destroy humanity outright, but could still disrupt climate enough to spark cascading crises. Grain shortages in one part of the world ripple into food price spikes elsewhere. Communities already living close to hunger would be pushed over the edge. Human conflict in one region could trigger starvation half a world away. In this way, nuclear catastrophe reminds us that borders are porous when it comes to the atmosphere, the oceans, and the climate. The danger of nuclear war is not only in deliberate attacks, but also in accidents and miscalculations. History records chilling near misses, radar systems misinterpreting the rising sun as incoming missiles, computer glitches signaling phantom launches, submarine officers debating whether to retaliate. In these moments, the fate of millions hinged on the judgment and restraint of a handful of individuals. That humanity survived these incidents is a testament to luck as much as design. The lesson is clear. As long as nuclear weapons exist, so too does the possibility of error. In the modern era, the number of nuclear weapons has declined from Cold War peaks, but thousands still remain. The United States, Russia, China, France, the United Kingdom, India, Pakistan, North Korea, and Israel possess arsenals with varying doctrines of use. Some nations pledge no first-use policies, others reserve the right to strike preemptively. Regional tensions, from South Asia to the Korean Peninsula to the Middle East, keep the risk alive. As global politics shift, the stability of deterrence is tested. The possibility of new arms races, modernization of arsenals, and erosion of treaties all complicate the landscape. Nuclear catastrophe is no longer a distant Cold War fear, but an ongoing global concern. Even without an all-out war, the existence of nuclear weapons exerts psychological weight. Literature, film, and art have grappled with the imagery of nuclear fire and frozen aftermaths. From post-apocalyptic fiction to sobering documentaries, culture reflects our anxieties and our resilience. The symbolism of the mushroom cloud has become shorthand for human folly and power alike. For those who grew up during the Cold War, it is a memory of living under constant threat. For newer generations, it may seem abstract, but the weapons remain real, humming quietly in silos and submarines across the world. The human body is especially vulnerable to radiation. Unlike visible flames or collapsing buildings, radiation damage is invisible, silent, and insidious. It alters DNA, weakens immune systems, and seeds cancers that may not appear until years later. Survivors of Hiroshima and Nagasaki taught the world about these long-term effects, as did the displaced communities around Chernobyl. To imagine a nuclear exchange on a large scale is to imagine not just cities erased, but generations scarred. Children yet unborn could inherit the damage. Entire ecosystems could carry the marks of radiation, with plants and animals mutating or struggling to survive in contaminated zones. Man-made catastrophe is not limited to nuclear weapons alone. Chemical weapons, biological weapons, and advanced cyber warfare all carry their own forms of risk. But nuclear arms stand apart because of their scale and speed. No other tool combines such immediacy of destruction with such enduring aftermath. They embody the dual edge of human ingenuity, the ability to split atoms, to harness immense energy, and to unleash consequences beyond full control. In contemplating nuclear catastrophe, we confront the larger theme of how human conflict intersects with technology, how ambition can outrun wisdom, and how survival depends not just on power, but on restraint. Yet even in this sobering reflection, there is space for resilience and hope. Arms control agreements, non-proliferation treaties, and grassroots activism have reduced risks before. International cooperation has dismantled warheads, monitored reactors, and opened lines of dialogue. Survivors of Hiroshima and Nagasaki, known as hibakusha, have dedicated their lives to speaking out so that future generations never forget the human cost. Peace movements across decades remind us that awareness and advocacy can shift political choices. Nuclear catastrophe remains a possibility, but it is not an inevitability. Human beings can choose restraint, can choose cooperation, can choose to step back from the brink. The question of how the world might end is never only about forces beyond us, like asteroids or supernovae. It is also about the choices we make as a species. Nuclear winter stands as one of the starkest examples. An end that would not arrive from the cosmos but from within. A mirror of our conflicts amplified to planetary scale. To reflect on it with calm curiosity is to hold two truths at once: that we live with this danger, and that we hold the power to lessen it. In the end, the story of nuclear weapons is also the story of responsibility. Fire harnessed without caution can consume the very hearth that nurtures it. The atom unlocked gave us both clean energy and devastating weapons. The The same ingenuity that built bombs also built medicines, satellites, and the technology to study the stars. The challenge lies in channeling that creativity towards survival rather than destruction. If humanity can imagine the end of the world, it can also imagine ways to prevent it. To sit quietly with the idea of nuclear catastrophe is not to dwell in fear, but to recognize fragility and resilience intertwined. The world may hold weapons that could darken the skies, yet it also holds people who work tirelessly to prevent that outcome. It may hold arsenals capable of ending millions of lives, yet it also holds generations who dream of peace. And so, when we ask how the world might end, nuclear winter reminds us of a sobering possibility, but also of the urgent need to live wisely, to choose carefully, and to honor the fragile balance that keeps life burning bright beneath the sun. Artificial intelligence is one of the most fascinating and unsettling topics of our time, a creation that sits at the intersection of human brilliance and human vulnerability. Unlike earthquakes or asteroids, the risks here are born from within, technologies built to extend our capabilities, but carrying with them uncertainties we cannot fully predict. To ask whether artificial intelligence and other emerging technologies will save us or harm us is to ask one of the central questions of the modern age. The story is not only about machines and code, but about how human choices, human values, and human limits shape the path forward. At its most basic, artificial intelligence refers to systems designed to learn, adapt, and make decisions. In the last few decades, advances have been astonishing. Computers that once filled entire rooms now live in our pockets, capable of translating languages, navigating streets, recognizing faces, and generating text or art. These tools hold enormous promise. They can accelerate medical research, detect climate patterns, optimize agriculture, and analyze vast amounts of data in ways no human mind could manage alone. The same algorithms that suggest songs to listen to or help doctors read medical scans also hint at futures where technology becomes deeply embedded in every part of life. The promise is dazzling, yet the risks grow in parallel. One of the most frequently discussed risks is automation. Artificial intelligence is already reshaping economies by taking over tasks once reserved for human workers. In factories, warehouses, and offices, machines sort, calculate, and manage with efficiency that does not require breaks, salaries, or sleep. For some, this is liberation, freeing people from repetitive or dangerous work. For others, it is a source of deep anxiety, threatening livelihoods, careers, and the sense of purpose tied to labor. If societies cannot adapt quickly enough, automation may widen inequality, concentrating wealth in those who own the machines while leaving others behind. The collapse here would not be of fire or radiation, but of social cohesion and trust, a slow unraveling born of imbalance. Beyond economics lies the question of control. Artificial intelligence operates through layers of algorithms that often grow too complex for even their creators to fully explain. When systems learn patterns, they sometimes reach conclusions in ways opaque to humans. This black box nature of AI raises concerns about accountability. If an autonomous vehicle makes a fatal mistake, who is responsible? The programmer, the manufacturer, or the algorithm itself? If a financial system driven by AI triggers a collapse, how do regulators respond to decisions no one fully understood in real time? The risk is not only that machines act wrongly, but that humans struggle to assign blame, enforce rules, or build trust in systems we cannot fully see inside. The dangers grow sharper when AI intersects with military technology. Already, governments experiment with autonomous drones, cyber defense systems, and predictive algorithms for conflict. In theory, machines could reduce casualties by acting with precision faster than human reaction. In practice, the delegation of lethal decisions to algorithms raises profound moral and practical dangers. What happens if an AI misreads a signal and escalates a conflict? What if autonomous systems on opposing sides enter into feedback loops that spiral into unintended battles? The risks mirror those of nuclear weapons, but with a new twist. Decisions unfolding at speeds beyond human intervention, creating crises where leaders may not have time to pause or correct. Cybersecurity adds another layer to this picture. Modern societies are built on networks, power grids, hospitals, banks, transportation, and communication all run on digital foundations. Artificial intelligence enhances the ability to defend those systems, but also increases the sophistication of attacks. Hackers aided by AI can probe for vulnerabilities faster, disguise intrusions more cleverly, and launch misinformation campaigns at scale. Entire elections could be swayed by deepfake videos or automated disinformation. Critical infrastructure could be crippled by AI-driven assaults. The threat is not always obvious explosions or visible destruction, but silent breakdowns of trust, systems, and information. The invisible collapse of the digital skeleton that modern life relies upon. Biotechnology, too, intertwines with these risks. Advances in gene editing, synthetic biology, and medical engineering promise cures for disease and breakthroughs in agriculture. But they also open doors to engineered pathogens, lab accidents, or misused technologies. When artificial intelligence accelerates biotechnology research, discoveries come faster, but so too do potential dangers. A virus designed with unintended consequences could spread globally before containment was possible. Genetic tools in the wrong hands could become weapons rather than cures. The line between innovation and catastrophe grows thin when speed outruns caution. Philosophers and scientists also warn of existential risks. The possibility that advanced artificial intelligence could one day outstrip human control altogether. This is sometimes framed as the alignment problem. Even if an AI system is programmed with goals, if those goals are misinterpreted, the consequences could be disastrous. An AI told to maximize paperclip production in theory might consume all resources in pursuit of that task, ignoring human needs entirely. While this example is deliberately exaggerated, it illustrates a deeper fear. Once a system exceeds human intelligence, ensuring its goals remain compatible with human survival could be more complex than we anticipate. The possibility of runaway superintelligence remains speculative, but it looms in conversations about how far to push innovation before building guardrails. At the same time, artificial intelligence is not inherently a threat. It also carries profound potential for solving the very problems that imperil humanity. Climate change models enhanced by AI can project future scenarios with greater accuracy, helping societies prepare for floods, droughts, and storms. Medical AI can scan millions of cases to identify new treatments, accelerate vaccine development, and track outbreaks before they become pandemics. Renewable energy systems guided by machine learning can balance grids, optimize storage, and reduce waste. In these ways, the same algorithms that raise alarms may also be the tools that extend life, resilience, and stability. The difference lies in governance, ethics, and the choices humans make about where and how the technology is applied. Ethical questions lie at the heart of technological risk. Who decides how AI is built and deployed? Whose values are encoded in its design? Biases in training data can lead to biased outcomes in hiring, policing, healthcare, and beyond. If unchecked, artificial intelligence may reinforce existing inequalities rather than reduce them. Building systems that are transparent, fair, and accountable requires deliberate effort, global cooperation, and humility about the limits of technology. Left to the fastest innovators alone, risks may grow unchecked. Guided by careful frameworks, the promise can be realized while dangers are contained. History shows that every great leap in technology carries both benefits and hazards. The harnessing of fire, the invention of electricity, the splitting of the atom, All gave humanity new powers, but also new dangers. Artificial intelligence continues this pattern, amplified by its speed and scope. What makes it especially pressing is its integration into every field: medicine, military, communication, education, entertainment, and governance. The risks are not confined to one sector, but ripple across the entire fabric of human life. That interconnectedness means both that failure could spread widely and that solutions could benefit many at once. In contemplating technological risks, one theme recurs: resilience. Societies that anticipate dangers, regulate wisely, and prepare fallback systems are less likely to collapse under strain. Those that chase speed without safety may stumble. The future of artificial intelligence is not written in stone. It is shaped by decisions: what investments are made, what rules are enforced, what values are prioritized. Technology may be born in code and circuits, but its trajectory is guided by human culture, politics, and morality. There is also the question of psychological impact. Living in a world where machines compose music, write essays, paint pictures, and even simulate companionship raises profound questions about identity. What does it mean to be human when algorithms can mimic creativity, empathy, or conversation? Some find this thrilling, others unsettling. The risk is not only external collapse, but internal confusion. Societies struggling to define meaning, purpose, and uniqueness in a world where the line between human and machine blurs. And yet, as with nuclear fire, the story is not only one of peril, it is also one of possibility. Artificial intelligence can help prevent famine, predict earthquakes, detect diseases early, and explore the cosmos. Biotechnology can cure blindness, grow new organs, and restore ecosystems. Cybersystems can knit the world closer together, amplify education, and coordinate solutions to global challenges. The same tools that frighten us also inspire hope. The difference lies in our wisdom, humility, and restraint. When we ask how the world might end, artificial intelligence and technological risk remind us that not all endings come from outside. Some could be born of ambition without foresight, of speed without reflection, of invention without responsibility. But in the same breath, these creations could also extend human survival far longer than nature alone would allow. They may help us shield the planet from asteroids, adapt to climate change, or even spread beyond Earth to other worlds. They are both sword and shield, mirror and magnifier. To sit quietly with this thought is to recognize both fragility and strength. Humanity has always been a species of invention, creating tools to extend reach, build shelter, and tell stories. Artificial intelligence is simply the latest and most powerful of these tools. Whether it becomes our downfall or our safeguard will depend on whether we guide it with care, respect, and humility. The question is not whether the technology is dangerous, but whether we are wise enough to live with it. In the end, artificial intelligence is not the villain of the story, nor the savior. It is a reflection of us, our ingenuity, our impatience, our hope, and our fear. It shows us that the line between survival and collapse can be thin, but it also shows us that within our own choices lies the ability to walk that line carefully. The end of the world may not come from machines at all, but from the failure to recognize that we are their stewards. And so, in exploring this chapter of possibility and peril, we are really exploring ourselves, the creators of tools, the dreamers of futures, and the guardians of tomorrow. The dream of leaving Earth has lived in human imagination long before rockets ever touched the sky. When people look up at the stars, they do not only see distant lights, they see possibility, hope, and perhaps an escape. The idea that humanity might build colonies on Mars, explore exoplanets, and one day survive by reaching beyond Earth is both a story of survival and of ambition. It touches science, philosophy, culture, and fear all at once. In asking how the world will end, it is natural to ask if leaving Earth could allow life to continue elsewhere. Space ambitions and escape dreams are about far more than rockets. They are about what it means to be human in the face of cosmic fragility. Mars has become the most familiar symbol of these ambitions. Only a few worlds in our solar system offer even a glimmer of habitability, and Mars stands out because of its relative closeness and similarities to Earth. Its days are roughly the same length. It has seasons, polar ice, and landscapes that echo deserts and mountains we recognize. Yet, living there would be unimaginably hard. Mars is cold. Its thin atmosphere offers almost no protection from radiation, and liquid water is rare. Still, scientists and engineers imagine domed cities, underground habitats, and greenhouses that could sustain settlers. Mars is a test case for whether humanity can take fragile life and plant it in alien soil. It represents resilience, but it also forces us to see how dependent we are on Earth's balanced systems. Beyond Mars, telescopes search for exoplanets orbiting other stars. Over the last 2 decades, discoveries have multiplied, revealing worlds with rocky surfaces, oceans, or atmospheres in the so-called habitable zone, where liquid water could exist. Each new discovery ignites wonder. Could these planets be new homes? Could life already exist there, waiting for us to notice? The challenges are staggering. Even the closest star systems are light-years away, requiring travel times far beyond a single human lifetime with current technology. Colonizing exoplanets may remain a dream for centuries or longer. Yet the knowledge that they exist expands our vision, reminding us that Earth is not unique, and perhaps neither is life. Some imagine space stations and orbital habitats as more practical first steps. Instead of reaching other planets, we might build enormous rotating structures that mimic gravity and house thousands of people. Science fiction often portrays these stations as gleaming, self-sustaining worlds in miniature. Engineers debate whether asteroid mining could provide the raw materials for such habitats, and whether energy from the sun could power them. These ideas remind us that survival may not mean settling a distant planet, but constructing environments that carry pieces of Earth into space. The ambition is less about abandoning Earth and more about multiplying safe places where life can endure. Escape dreams are driven partly by fear. People see threats: climate change, nuclear war, pandemics, ecological collapse, and wonder if Earth itself may someday no longer sustain us. Colonies on Mars, or habitats in orbit, become safety nets, arcs carrying humanity away from disaster. This is sometimes called the backup planet idea. But others caution that treating space as a backup risks neglecting Earth, our only proven home. No technology yet can make Mars as comfortable as even the harshest desert on Earth. Escaping the planet does not free us from the responsibility of protecting it. Still, the dream persists, fueled by both survival instinct and a sense of adventure. Space ambitions also carry cultural meaning. They echo humanity's long history of exploration, from crossing oceans to charting new continents. Just as ancient voyagers launched ships into unknown waters, modern explorers imagine launching rockets into the void. The risks are enormous, the odds uncertain, but the spirit is familiar. Exploration has always been about more than survival. It is also about curiosity, identity, and the longing to see what lies beyond the horizon. Space is the newest horizon, vast and seemingly endless, inviting us to imagine futures we cannot yet touch. Technology slowly shifts dreams into possibilities. Rockets reusable enough to reduce costs, spacecraft that can carry heavier loads, life support systems designed to recycle air and water, all are steps toward feasibility. Experiments on the International Space Station teach us how human bodies respond to weightlessness, radiation, and isolation. Private companies join government agencies, competing and collaborating to push further. While a permanent Mars settlement is still out of reach, the groundwork is being laid. Every launch, Every experiment, every new discovery of an exoplanet adds another piece to the puzzle of survival beyond Earth. Yet survival in space is not only about engineering, it is also about psychology and community. Life in confined habitats, far from Earth, would challenge the human mind as much as the body. How do people adapt to long isolation? How do small groups manage conflict, boredom, and the weight of distance from home? Historical lessons from polar expeditions, submarines, and space stations hint at both resilience and fragility. Escape dreams must include not just airlocks and food systems, but also art, culture, companionship, and purpose. A colony is not only about keeping bodies alive, it is about creating lives worth living. Philosophically, space ambitions raise questions about destiny. Some argue that humanity is meant to spread beyond Earth, that life's purpose is expansion, exploration, and survival across time and space. Others argue that focusing on space distracts from caring for the planet we already have. Both perspectives reveal deep truths. The Earth is precious, irreplaceable, and fragile. But the cosmos is vast, and staying forever on one world leaves us vulnerable to its eventual end. Perhaps the balance lies not in choosing one path, but in holding both together, preserving Earth while reaching for the stars. The risks of space colonization are sobering. Radiation exposure beyond Earth's magnetic shield, microgravity weakening muscles and bones, unpredictable solar storms, and the difficulty of growing food far from Earth's ecosystems all stand as obstacles. Each requires solutions that are expensive, uncertain, and fragile. Space does not welcome us. It is cold, airless, and hostile. Surviving there will demand constant effort. This is why escape dreams remain dreams for now. They remind us of what we might achieve, but they also show how deeply we depend on the natural balance Earth provides without asking anything of us. Still, there is wonder in imagining. A city beneath a Martian dome glowing against a red horizon. A rotating habitat with forests, rivers, and skylines curving upward into the distance. Children born on Mars, who look at Earth as the ancient homeland. Explorers sailing solar sails between stars. These visions may never come to pass, but they shape how humanity thinks about survival, possibility, and meaning. They allow us to ask not only how the world might end, but how life might continue even after Earth has changed beyond recognition. Exoplanets remind us of another possibility. We may not be alone. If life has evolved elsewhere, then survival may not only be about carrying human life forward, but also about joining a larger story of biology in the universe. Escape dreams then become connection dreams, a way to imagine humanity as part of something bigger than itself. Whether we find life elsewhere or not, the search deepens the sense that space ambitions are not just about survival, but about understanding who we are. Space also offers perspective. From orbit, astronauts describe the overview effect, a sudden awareness of Earth's beauty and fragility, floating alone in the blackness of space. Seeing the planet as one whole reminds us that the divisions and conflicts we focus on are small compared to the shared home we all rely on. Escape dreams do not erase that truth. If anything, they magnify it. They show us that Earth is a cradle of life, and that leaving it behind, even temporarily, would only deepen our gratitude for what it gives us freely. In the end, space ambitions are neither purely practical nor purely fantastical. They are a mirror reflecting humanity's deepest instincts, to survive, to explore, to imagine. They show us both the limits of our current technology and the vastness of what remains possible. Colonies on Mars, exoplanet exploration, orbital habitats. These are not only escape plans. They are symbols of resilience, curiosity, and hope. They ask us to think of endings not only as finality, but also as thresholds, doors through which life may continue in new forms and places. When we ask whether humanity can survive by reaching beyond Earth, The answer is both yes and no. Yes, it is possible that someday technology will make it feasible to live elsewhere. No, it cannot replace Earth, at least not for a very long time. The world we have now remains our most precious resource, our most reliable home. Escape dreams remind us that endings are never the whole story. There are always new horizons, even if reaching them takes centuries. So we return to the quiet thought. The world may end, but life may not. Whether on Mars, in orbit, or on a distant exoplanet, humanity may yet carry forward the fragile spark of existence. Space ambitions are not a guarantee, but they are a reminder that even in imagining endings, we are drawn to beginnings. In the silence of the cosmos, we look not only for escape, but for continuity, for meaning, and for the reassurance that the story of life does not stop at Earth's edge. The story of civilization has always been tied to energy and resources. From the first fires kindled in caves to the global grids of electricity that light our cities today, every advance, every empire, and every collapse has been linked to how humans capture, store, and use the energy of the world around them. When people speak of how the world might end, one of the most sobering possibilities is not a sudden cosmic strike or a single catastrophe, but the slow unraveling of societies through the exhaustion of resources and the fragile interdependence of systems. Energy fuels agriculture, industry, medicine, communication, and even the smallest comforts of daily life. Without it, civilization's web begins to fray. Resource depletion, blackouts, and the chain reactions of economic and societal collapse are not as dramatic as asteroids or supervolcanoes, but they may be more immediate and more within human control. Energy is both invisible and everywhere. The heat in homes, the fuel in cars, the electricity that powers phones, the chemical bonds in food, all of it is energy in different forms. Civilizations rise by mastering energy. The Sumerians irrigated fields with river energy. The Greeks harnessed wind in sails. The Industrial Revolution turned coal into steam, steel, and trains. The 20th century ran on oil, natural gas, and vast electrical networks. With each transition, the world population grew, cities expanded, and life expectancy lengthened. Yet each step also increased dependence. The more people rely on complex systems, the more vulnerable they become if those systems falter. Resource depletion is not only about running out, but about imbalance. Oil reserves do not vanish overnight, but as the easiest fields are drained, extraction becomes harder, riskier, and more expensive. Water aquifers do not dry in a day, but overpumping shrinks them until wells go barren. Forests fall tree by tree, soils lose nutrients season by season. Collapse comes not from a single empty tank, but from accumulated stresses reaching a tipping point. Economies woven around constant supply struggle when supply dwindles. Blackouts happen not only because fuel is missing, but because grids, demand, and climate extremes push fragile systems past their limits. History offers sobering lessons. The fall of the Mayan civilization is linked in part to deforestation and drought. The collapse of Mesopotamian agriculture came when irrigation salinated the soil, reducing harvests. The Easter Island society carved magnificent statues, but cut down so many trees that the ecosystem could not support them. These stories are reminders that even great cultures can falter when resources are misused or overused. Modern civilization is far more complex and interconnected, but it is not immune. Globalization ties supply chains so tightly that a disruption in one region can ripple worldwide. A drought in one grain belt raises bread prices everywhere. A cyber attack on a power grid can shut down entire cities. Fragility is woven into strength. Energy security is not only a technical matter, it is political, economic, and cultural. Nations compete for oil reserves, pipelines, and rare earth minerals. Wars have been fought not only over borders, but over resources hidden beneath soil and sea. Blackouts in cities spark unrest, protests, and political pressure. When gas prices rise, economies tremble. Energy shapes geopolitics, alliances, and rivalries. The fear of scarcity can fuel conflict as much as scarcity itself. If the world faces collapse, it may come less from the absence of resources than from the human responses to dwindling supplies. One of the greatest vulnerabilities is electricity. Modern life is threaded with electric power. Hospitals, transport systems, data centers, and homes depend on it constantly. A blackout for an hour is an inconvenience. A blackout for a week is a crisis. Extended collapse of grids could spiral into chaos, disrupting food supply chains, medical care, communication, and water purification. Climate change makes grids more fragile by pushing heat waves that overload systems, storms that tear down lines, and floods that drown substations. As societies digitize more of life, the demand for steady electricity rises, but so does the exposure to disruption. Fossil fuels remain the backbone of civilization, but they carry two risks: depletion and damage. Oil fields deplete, and coal mines are finite. Burning them adds carbon to the atmosphere, heating the planet and destabilizing ecosystems. The irony is sharp. Using energy depletes both the resource itself and the stability of the systems that rely on it. Renewable energy, wind, solar, hydro, offers hope, but it requires vast infrastructure, rare minerals for batteries, and stable grids to integrate fluctuating supply. Transitioning energy systems is one of humanity's greatest challenges. Delay makes the risks sharper: shortages, price shocks, and accelerated climate disruption. Resource collapse does not affect all regions equally. Wealthier nations often buffer against shortages with imports, reserves, and technology, while poorer regions face scarcity more directly. Drought, deforestation, and desertification hit hardest where adaptive capacity is weakest. This imbalance creates another layer of fragility: migration pressures, competition over water, and rising inequality. Collapse may not look like one global fall, but like a patchwork of crises spreading unevenly, destabilizing societies in waves. The chain reactions of collapse are subtle but relentless. Imagine a severe drought reducing crop yields. Prices rise, families struggle, unrest spreads. Governments increase subsidies, straining budgets. Water shortages push migration from rural to urban areas, stressing cities. Conflicts emerge over shrinking rivers and lakes. Energy demand rises as regions turn to desalination, but power grids strain under the load. Blackouts trigger further unrest. A crisis that begins with water ripples into politics, economy, and security. Collapse is not a single event, but a cascade. Civilization's complexity is both a strength and a weakness. The internet connects billions, but if servers fail, information flow halts. Global shipping brings goods across oceans, but port blockages or fuel shortages ripple instantly. Financial systems link economies so tightly that shocks spread faster than governments can respond. Interdependence means that collapse in one sector can ignite collapse in another. Energy, resources, food, water, finance, and politics are threads of one fabric. Pull hard enough on any, and the fabric unravels. Yet collapse is not inevitable. Awareness of fragility brings opportunities for resilience. Societies experiment with renewable energy, decentralized grids, water recycling, soil restoration, and circular economies. Some communities focus on local food systems to buffer against global shocks. Engineers design smarter grids, batteries, and conservation methods. Collapse is a possibility, but adaptation is equally real. Humans have faced shortages before and found ways to change. The question is not whether adaptation is possible, but whether it will be timely and widespread. The psychology of collapse is as important as the mechanics. Fear of scarcity can create hoarding, panic, and conflict even before resources truly run out. Rumors of fuel shortages can create lines at pumps that cause the very shortages people feared. Economic markets magnify perceptions into prices. Collapse begins not only in fields and grids, but in minds and expectations. Trust in systems and leaders becomes as vital as physical supplies. A society that believes it can endure has more tools for resilience than one that surrenders to despair. Energy is also about meaning. It powers not only survival, but identity. Cities lit at night symbolize progress. Transportation networks symbolize freedom. A blackout is not only darkness, it is a reminder of dependence, fragility, and vulnerability. Collapse challenges not only economies, but the narratives civilizations tell about themselves. If people imagine collapse as inevitable, they may act less to prevent it. If they imagine resilience, they may invest in preparation. Narratives shape futures. The end of civilization through resource depletion and blackouts is not sudden fire, but slow unraveling. It is fields yielding less grain, rivers running lower, grids flickering off more often. It is the quiet exhaustion of soil, the thinning of forests, the creeping rise of seas. It is protests over prices, migrations from drought, and tensions over water. The end may not arrive as one great fall, but as 1,000 smaller collapses merging into one. Yet within the possibility of collapse lies the possibility of reinvention. Humanity can choose to shift energy systems, conserve resources, and build resilience into networks. Collapse is one path among many, not destiny. Facing it calmly means seeing the risks without surrendering to fear. It means recognizing that civilization's survival is not guaranteed, but neither is its downfall. Both depend on choices, actions, and imagination. When people ask how the world will end, energy and resource collapse is one answer. But it is not a story of inevitable doom. It is a warning, a mirror, and a challenge. It asks whether humanity can learn from history, balance ambition with sustainability, and see fragility as a call to wisdom. The light of cities, the hum of machines, the warmth of homes, all remind us how much civilization depends on energy flowing steadily. To protect that flow is to protect life as we know it. To neglect it is to risk unraveling. The end of civilization could be a blackout. But the choice to keep the lights on belongs to us. The story of how the world might end does not always require massive asteroids or exploding stars. Sometimes the most unsettling possibilities hide in the smallest of scales. Humanity has long been humbled by the invisible. Microbes that leap between hosts, particles too small to see that topple empires, and technologies engineered at dimensions thinner than a strand of hair. Micro-threats, tiny dangers carried by viruses, bacteria, or human-designed machines, remind us that size does not determine impact. A single mutation in a cell can alter the fate of millions. A microscopic invention released without foresight could ripple through ecosystems and societies. The human imagination often pictures the apocalypse in grand terms, but science teaches us that endings can begin with things unseen by the naked eye. Viruses are among the oldest examples of microscopic risk. Long before modern technology, plagues swept across continents with invisible origins. Smallpox, carried in droplets of breath and lingering on cloth, reshaped civilizations, depopulated regions, and altered the course of history. Influenza mutated into global pandemics, some killing tens of millions in mere months. The Black Death, carried by fleas on rats, devastated Europe in the 14th century, its pathogen so small that no one at the time could even conceive of its existence. These lessons remain relevant. The 21st century has already lived through pandemics that remind us of fragility. Air travel shrinks distances, cities grow dense, and global networks ensure that a microbe appearing in one corner of the world can arrive on the other side within a day. The smallest mutation in a virus's genetic code can determine whether it remains a mild inconvenience or becomes a global threat. But microbes are not only ancient enemies, they are also part of the foundation of life itself. Bacteria digest food in our intestines, yeasts ferment bread and wine, and microbes in soil recycle nutrients that sustain crops. The danger comes when balance is lost, when a mutation shifts a harmless organism into a harmful one, or when human actions disturb ecosystems and release pathogens into new hosts. Deforestation, wildlife trade, and urban expansion bring humans into closer contact with animal reservoirs of disease. Zoonotic spillover, the leap of viruses from animals into humans, is one of the most pressing micro-threats of our era. It is a reminder that microscopic life is not inherently friend or foe, but that disruption can unleash risks that once slumbered quietly in forests, caves, or oceans. Beyond the natural world lies the frontier of engineered microbes. Advances in biotechnology have given humanity powerful tools. CRISPR allows genetic editing with precision that would have seemed miraculous only a generation ago. Synthetic biology can design microbes to produce medicines, fuels, or materials. These innovations promise enormous benefits: cures for diseases, solutions to climate challenges, and new ways to feed a growing population. Yet they also carry risks. A microbe designed to heal could mutate or escape control. Research conducted for defense could be misused for harm. Laboratories safeguard samples, but accidents occur, and human error is inevitable. The very precision of biotechnology makes it a double-edged sword, capable of saving lives, but also of creating dangers that evolve faster than our ability to contain them. Nanotechnology brings another dimension to the world of tiny threats. Nanobots, machines engineered at scales so small they could navigate through human bloodstreams, remain largely theoretical, but research in nanomaterials and nanoscale engineering advances rapidly. Already, nanoparticles are used in medicine to deliver drugs directly to cells, in industry to strengthen materials, and in electronics to shrink devices. The promise is extraordinary. Medical nanobots that repair tissues, clean arteries, or target cancer cells with surgical precision. Yet the risks are sobering. A nanobot designed to replicate or repair could, if uncontrolled, continue reproducing endlessly, a scenario scientists call the grey goo hypothesis, where self-replicating nanomachines consume available matter in a runaway chain reaction. While speculative, it illustrates how even beneficial designs must be approached with caution. Small does not mean harmless. The greatest risk from nanotech is not necessarily runaway machines, but unexpected interactions. Nanoparticles can behave differently from larger materials of the same substance, sometimes toxic to cells or disruptive in ecosystems. Their invisibility makes them hard to track. Once released, they could spread silently in air, water, or soil, interacting with biology in ways poorly understood. Just as microplastics now infiltrate oceans, soils, and even human bodies, nano-sized materials could accumulate and alter environments in subtle but widespread ways. The boundary between promise and peril lies in careful testing, transparency, and regulation. But history shows that technologies often spread faster than safeguards. What makes micro-threats so unsettling is their stealth. A nuclear weapon announces itself with a flash. An asteroid can be tracked across the sky. But a microbe, a mutation, or a nanobot begins silently, invisibly, growing beneath notice until it has already spread. By the time symptoms appear in patients, by the time contamination is detected in water, the threat has multiplied. Speed and invisibility make micro-threats uniquely dangerous. They undermine the sense of security humans find in sight, because what cannot be seen can still shape destiny. Society's response to micro-threats is as important as the threats themselves. Pandemics reveal not only biological vulnerability, but also social fragility. Fear spreads faster than viruses. Rumors undermine trust in science. Panic buying empties shelves. Borders close, economies falter, and inequalities deepen. In the same way, fear of nanotechnology could trigger backlash, regulation, or rejection, even of beneficial applications. The danger is not only in the tiny agent, but in the massive human reactions it provokes. Collapse does not come solely from microbes or machines, but from the way fear, mistrust, and poor coordination amplify their effects. Preparedness requires humility. Vaccines, treatments, and monitoring systems reduce risks, but they require cooperation across nations. Laboratories studying dangerous microbes must be transparent. Researchers designing nanotech must anticipate not only intended uses, but unintended consequences. International treaties can help, but enforcement is challenging. Unlike large weapons or missiles, microbes and nanomaterials are small, portable, and replicable. Control depends on culture as much as on technology, a culture of responsibility, caution, and ethical awareness. The challenge of micro-threats is not merely scientific, but moral. How to wield immense power at microscopic scales without hubris. One of the paradoxes of micro-threats is that they are often born from progress. Antibiotics, one of the greatest medical advances, gave humans the power to fight bacterial infections that once killed millions. But widespread use led to resistant strains, bacteria evolving defenses against the very drugs meant to stop them. Superbugs, resistant to multiple antibiotics, now pose a growing challenge. In trying to master microbes, humanity created new pressures that shaped them into stronger adversaries. Similarly, the pursuit of new nanomaterials may unlock powerful solutions, but could also create novel risks. Progress is not linear triumph, but a cycle of solving one problem while generating another. The philosophical weight of micro-threats lies in their reminder of interconnection. The world is vast, yet it can be shaken by what cannot be seen. Human bodies, ecosystems, and technologies are networks that respond to the smallest changes. A single gene edit, a single nanoparticle, a single virus can ripple outward. The end of the world or the collapse of civilization may not arrive in flames, but in fevers, in failures of microscopic safeguards, in subtle shifts that accumulate unseen until too late. To face this possibility with calm curiosity means to respect the power of the small without surrendering to fear. At the same time, it is important to note that not every micro-invention or mutation spells disaster. The same forces that could threaten can also heal. Engineered microbes can produce life-saving insulin, break down pollutants, and generate renewable fuels. Nanoparticles can deliver targeted cancer therapies with fewer side effects than traditional treatments. The duality is ever present. What can harm can also help. Recognizing both sides is key to balance. The challenge is not to reject the small, but to guide it wisely. The end of the world through micro-threats is not about inevitability, but about vigilance. It is about seeing the invisible as part of the larger picture, acknowledging that the smallest scales of life and technology may hold the keys to humanity's endurance, or its unraveling. If collapse comes through tiny dangers, it will not look like explosions or meteors, but like silence before symptoms, like materials quietly spreading before discovery. It will be an end born not of size, but of subtlety. To imagine the end of the world through micro-threats is to imagine humility. The vastness of space and the grandeur of geological upheavals are intimidating, but it is the unseen, the invisible, that may be most profound. The smallest mutation in a virus, the tiniest shift in a protein, the invisible spread of a nanomaterial, these carry the potential to shape futures. Humanity's survival rests on recognizing that scale does not determine consequence. The greatest dangers may arrive quietly, on a scale too small to see, yet vast enough to change. The night sky is full of light, yet also full of silence. Billions of stars burn in the vastness, each one potentially surrounded by planets, some rocky, some watery, some perhaps capable of life. When we look up, we see possibility. So many suns, so many chances. And yet, when we listen, the universe does not answer back. No radio signals drift in from intelligent neighbors, no spacecraft appear on the horizon, no unmistakable evidence of civilizations older and wiser than ours. This puzzle, known as the Fermi paradox, sits at the crossroads of wonder and dread. If the universe is so vast, if life has had billions of years to emerge, why do we hear only silence? The paradox takes its name from physicist Enrico Fermi, who, during a casual lunch conversation in the 1950s, asked a question both simple and haunting. Where is everybody? Astronomers estimate that our galaxy alone contains hundreds of billions of stars, many with planets in the so-called habitable zone, where liquid water could exist. With so many opportunities, even a modest probability of life should result in countless civilizations spread across the cosmos. Some of those civilizations, given time, could develop technologies capable of communication, exploration, even colonization. Yet despite decades of searching, no definitive signal has ever been detected. This silence might be telling us something unsettling about survival. Perhaps civilizations rise but do not last. Perhaps intelligence is self-limiting, doomed to collapse before it can travel far or endure long. The universe could be full of ruins, not of thriving empires. Just as species on Earth often flourish briefly before extinction, so too might civilizations bloom and vanish, leaving little trace across cosmic distances. The absence of evidence may be less about life failing to appear, and more about it failing to persist. Some scientists argue that we should not be surprised by the silence. Interstellar distances are immense, measured not in miles, but in light years. Even if a civilization were broadcasting, its signals might take thousands of years to reach us, by which point the senders may have long disappeared. Likewise, our own attempts to listen through radio telescopes have sampled only a tiny fraction of the sky, across narrow frequency bands, for a relatively short time. Silence may not mean absence, only that we have not yet tuned into the right channel at the right moment. Still, the paradox remains unsettling. Probability suggests abundance, yet our instruments record quiet. There are many possible answers to the paradox. One is that intelligent life is incredibly rare, perhaps unique. Life may be common in microbial form, but vanishingly unlikely to evolve into complex organisms. The Earth may be an outlier, a rare cradle where countless conditions aligned just right. If so, the silence is simply the echo of our loneliness, a reminder that we are fragile anomalies in a universe otherwise indifferent to complexity. Another possibility is that civilizations tend to self-destruct. The same intelligence that allows species to invent technology may also bring weapons of destruction, ecological collapse, or runaway systems they cannot control. The silence could be the graveyard of ambitions, each society reaching a threshold of power and then extinguishing itself. Nuclear weapons, climate change, artificial intelligence. Our own era is littered with challenges that could topple us before we ever send ships to the stars. Perhaps the Fermi paradox is less a mystery and more a mirror, reflecting back our own vulnerabilities. Still others suggest that civilizations may choose silence. Broadcasting signals across space reveals location, and in a universe of unknowns that could be dangerous. Predators might listen. Resources might attract competitors. In this view, intelligent beings learn to hide, to cloak themselves in quiet. We search for signals, but advanced societies may be deliberately avoiding detection. The silence, then, is not absence, but caution, a cosmic library where every book is closed, every story guarded. The paradox has philosophical weight. If we are alone, then Earth carries an unimaginable burden, the only island of thought in a vast ocean of matter. If we are not alone, but the others have already fallen, then our task is to avoid their fate. Both possibilities inspire humility. Survival is not guaranteed. Silence is not safety. The fragility of civilizations is not just an abstract cosmic theme. It is written in the very fabric of our own history. Nations have risen and collapsed, species have flourished and vanished, and the planet has seen extinctions on a massive scale. The question is whether humanity can step beyond those cycles, or whether we too will fade into the quiet. The paradox also connects to extinction on a universal scale. Stars burn and die. Galaxies collide. Black holes consume. The universe itself moves toward greater entropy, a slow dimming across trillions of years. Even if civilizations endure locally, the backdrop is one of inevitable loss. The silence, then, may be a preview of the far future, a universe where voices flickered briefly and then went dark, leaving behind nothing but empty starlight. And yet, there is also hope in the silence. It is possible that civilizations exist, but the distances are simply too great, the timelines too misaligned. We may be early listeners, tuning in before the great conversation has begun. The silence could be temporary, a pause before connection. In that case, our survival matters all the more. To last long enough to hear another voice, to send our own signals far enough to be received, requires avoiding the pitfalls that may have silenced others. Climate stewardship, peace, sustainable technology, these are not just earthly concerns, but cosmic ones. The Fermi paradox is not only about astronomy, it is about humanity's place in time. Each generation looks at the stars with the same question: are we the only ones? The absence of evidence forces us to reflect on our responsibilities here and now. Whether life elsewhere thrives or perished, whether the galaxy is crowded or empty, the lesson may be the same. Survival requires care, foresight, and resilience. Fragility is universal. The silence is a teacher. Consider also how the paradox shapes imagination. Writers, artists, and dreamers have filled the silence with stories: alien civilizations hiding, great filters blocking advancement, ancient ruins scattered across galaxies. These tales are not just entertainment, but reflections of human anxiety and hope. In myths of alien invasions or interstellar friendships, we project our own struggles with cooperation, fear, and ambition. The silence becomes a canvas, painted with the colors of human imagination, each interpretation a mirror of our own uncertainties. Science, too, continues to search. Projects like SETI listen for faint signals. Astronomers study exoplanets for signs of atmosphere and water. Instruments detect whispers of molecules that could hint at biology. The search is a quiet act of optimism, a refusal to accept that silence means nothing. Every new telescope pointed skyward is a declaration of faith in discovery, a belief that the universe still holds voices waiting to be heard. At the same time, extinction remains a sobering possibility. The silence may not only be about the absence of others, but about the inevitability of endings. Civilizations, like stars, may be temporary. The Fermi paradox could be a cosmic reminder that survival is fragile, that endurance is rare, that our own story must be written with care if it is to last. To face that with calm curiosity is not to despair, but to prepare, to accept that fragility is part of existence and that meaning comes not from guarantees, but from the effort to continue. The quiet night sky does not give us answers, but it gives us perspective. Billions of stars shine, and we are here to notice them. Whether alone or not, whether destined for collapse or for long endurance, humanity has the rare gift of awareness. The silence of the universe is not empty. It is full of lessons about humility, survival, and possibility. If no one else speaks, then our responsibility is even greater. To keep the voice of life alive, to carry thought, culture, and memory forward against the quiet. The end of the world may not come from cosmic collisions or blazing suns. It may come from silence, the silence of civilizations that could not endure, the silence that lingers after extinction. The Fermi paradox is less a riddle to be solved and more a reminder to live wisely in the face of fragility. The universe may not answer, but our choices today echo into its vastness. Survival, resilience, and care may be the only ways to turn silence into song. The story of endings is not always sudden. Sometimes it is not fire or collision, not plague or eruption, but something quieter, slower, and more inevitable than any single disaster. Imagine not a bang, but a long sigh stretched across unfathomable time. That is the idea of entropy, the concept at the heart of thermodynamics, and the theory of the heat death of the universe. It is a vision not of violent collapse, but of gradual fading, a universe running down like a clock that has no hand to wind it back up. This idea may seem abstract, but it is one of the most profound insights science has ever offered about the fate of everything: stars, galaxies, planets, and life itself. Entropy, put simply, is the measure of disorder or randomness in a system. In everyday life, you see entropy when a hot drink cools, when ice melts, or when smoke disperses in the air. Energy naturally spreads out. Heat flows from warm to cold. Order collapses into disorder unless effort is made to preserve it. In physics, this principle is enshrined in the second law of thermodynamics. In any closed system, entropy never decreases. It either rises or, at best, stays the same. And when you take that rule and scale it up to the entire universe, the result is staggering. Right now, the universe is full of energy gradients, differences between hot and cold, between bright and dark, between dense and empty. Stars burn by fusing hydrogen into helium, releasing radiation that warms planets and allows life to grow. Galaxies glitter with billions of suns. Black holes stir the space around them, and even the faint glow of the cosmic microwave background whispers of a hot beginning. But over time, those gradients will even out. Stars will exhaust their fuel, black holes will evaporate, and the universe will grow more uniform. In the end, entropy wins. The heat death is not a fiery explosion, but rather the absence of usable energy. Heat in physics does not just mean warmth, but energy in motion. For life, machines, or stars to exist, there must be differences. Hotter here, colder there, because energy flows from one to the other, driving change. But in a universe that has reached maximum entropy, no such differences remain. Everything is the same dull temperature, stretched across infinite space. There is no free energy left to do work, no way to build complexity, no fuel for life or thought. It is not death by destruction, but death by exhaustion, a cosmic quiet, where nothing more can happen. How does this unfold? It begins with stars. Our own sun will shine for billions more years, eventually swelling into a red giant and then settling as a white dwarf, a tiny ember glowing with the memory of its former brilliance. Other stars will live shorter or longer lives, depending on their mass, but all will eventually burn out. Massive stars collapse into neutron stars or black holes, smaller ones fade into dwarfs. Across trillions of years, even those remnants cool, leaving behind only faint husks in the darkness. Galaxies themselves will change. Right now, gravity pulls stars together into spirals and clusters, but as energy spreads, stars interact and scatter. Some will be ejected into the lonely intergalactic void. Others will drift closer to central black holes and be consumed. Over unimaginable spans of time, galaxies will lose their structure, dissolving into diffuse clouds of dead stars, failed stars, and black holes. The glittering night sky we see today will one day be empty, a darkness with only rare points of faint light. Black holes may seem eternal, but even they fade. Stephen Hawking's theory of Hawking radiation suggests that black holes slowly leak energy, emitting tiny particles over eons. For massive black holes, this process takes longer than the age of the universe so far, but it is not infinite. Eventually, even the largest will evaporate, leaving behind only a final burst of radiation, and then nothing. The objects once thought to be the ultimate anchors of the cosmos will themselves vanish. What remains after all this is not heat in the way we know it, but equilibrium. The universe will be full of particles, photons, and faint energy spread evenly across space. No gradients mean no engines, no movement, no possibility of new stars, new planets, or new life. Time continues, but events stop. It is called heat death, but in truth, it is closer to a cold death, the extinguishing of every difference that makes existence dynamic. This vision of the future is humbling, because it forces us to think on scales so vast they almost escape comprehension. We measure our lives in years, civilizations in centuries, stars in billions of years, but the heat death stretches across timescales that dwarf all of those. Trillions, quadrillions, even Google years, a span so immense that our language struggles to capture it. In that scale, everything we know, from ancient history to modern technology to future empires, becomes a brief flicker. The end is not tomorrow or next millennium, but so far ahead it feels eternal, and yet it is still written into the physics that govern the present moment. Entropy is not only about endings, it is also about meaning. The fact that entropy increases explains why time seems to move in one direction. We remember the past, but not the future, because entropy was lower yesterday than today. Ice cubes melt, but never spontaneously refreeze. A glass shatters, but does not leap back together. The arrow of time is tied to entropy's rise. To contemplate the heat death, then, is to contemplate time itself, how it flows, why it flows, and how it may one day cease to carry meaning when nothing changes anymore. For humans, the heat death might sound bleak, but it is also strangely peaceful. It is not violence, but quiet, not destruction, but stillness. The end of all stories is not a scream, but a hush. In some ways, this mirrors our own lives. We burn brightly with energy, creating heat, motion, and complexity, but eventually we tire, and entropy wins. That does not mean life is meaningless. On the contrary, it makes meaning more precious. The universe may one day fade into silence, but here and now, in this brief window of gradients and differences, we have the chance to feel, to wonder, to create. Scientists continue to explore whether the heat death is inevitable. Some theories suggest alternatives. Perhaps the universe might collapse back in on itself in a big crunch, or perhaps it might cycle through endless expansions and contractions. Others consider dark energy, the mysterious force accelerating the universe's expansion, and whether it could lead to different fates, such as a big rip where everything is torn apart. But among these scenarios, the heat death remains the most widely accepted outcome, consistent with the second law of thermodynamics and the observations we have of cosmic expansion. The heat death raises philosophical questions as much as scientific ones. If everything ends in stillness, what is the purpose of striving? The answer may lie not in outcomes, but in process. The beauty of existence is not in its permanence, but in its fleeting brilliance. A sunset does not last forever, yet its brief glow is enough to inspire. Likewise, the universe's story is measured not only by its end, but by the journey, the galaxies, the stars, the lives that arose along the way. The heat death reminds us to treasure the present, to recognize the fragile miracle of energy still flowing, stars still burning, minds still thinking. In cultural imagination, the heat death often appears as a haunting metaphor. Poets write of fading lights, philosophers ponder the quiet of eternity, and storytellers imagine civilizations fighting against entropy with desperate technologies. Some dream of harnessing black holes as power sources, others of building machines that survive until the last particle decays. These tales may never be real, but they reflect a human truth. We resist endings, even as we know they are inevitable. In resisting, we create meaning. When you step outside at night and look up, you see a universe still alive with fire. The stars above you are engines fighting entropy, burning fuel to create light and warmth. The earth beneath you is sustained by those flows of energy, by gradients that make forests grow and oceans stir. All of this is temporary, but temporary does not mean trivial. The miracle is not that the universe will last forever, but that it lasts at all, and that we are here, aware of it, able to tell its story. The slow fade of entropy does not need to fill us with dread. Instead, it can inspire awe. Against the backdrop of eventual silence, life becomes more remarkable. Our thoughts, our cultures, our experiences, all of them are shaped in the narrow window when energy flows are still possible. In the distant future, long after stars have dimmed, the memory of this window will be gone. But here and now, it is real, vivid, and meaningful. The universe may end not with fire, but with equilibrium. No bright explosions, no sudden catastrophe, just the leveling out of every difference. A still sea of particles where once there were galaxies. A hush where once there was song. And yet, within that story lies the reminder to value the present, to care for the fragile balance that makes life possible, to seek meaning not in eternity, but in the precious impermanence of now. Entropy tells us that everything fades, but it also tells us why each moment matters. When people think about how the world might end, the first images are often of fire and floods, of stars collapsing or nuclear weapons turning cities to dust. Yet long before telescopes, satellites, or laboratories gave us scientific models of extinction, cultures across the globe imagined endings in ways that were as much about meaning as about destruction. These stories and philosophies were never only about doom. They were also about transformation, renewal, and the cycles of time. To contemplate the end, spiritually or philosophically, is to ask not just what happens to the earth, but what happens to us, our souls, our values, and our collective imagination.